So welcome again, and I'm going to hand over to my head of school, Nick Wenfield, to welcome you to the day.
Good morning. I'm Nick Wenfield, head of the Department of Civil and Environmental Engineering at Imperial College London, and it's my great pleasure to welcome you to this event. It's both a celebration of 10 years of the Centre for Systems Engineering and Innovation at Imperial, and also a forward-looking technical symposium. A diverse group of individuals from academia, industry and government have been involved with the Centre over the past 10 years, and a good number of them featured today. We are delighted to hear the Prime Minister just last week set out plans to put infrastructure at the centre of the government's economic growth strategy. And I'm pleased to say that amongst today's contributors is Nadim Zahawi, Minister for Business and Industry, whose responsibilities include infrastructure and construction. This was originally conceived as a physical event with us all in the same room. We believe that we have a digital format that will be equally stimulating, with the advantage that people from across the globe can be involved without the great time commitment and carbon footprint associated with coming to London. I'd like to convey my special thanks to Ray O'Rourke, founder and CEO of Lang O'Rourke, who had the vision and energy to help create and fund the centre, to Professor David Fisk for directing the centre for its first 5 years, and to Professor Jennifer White, Lang O'Rourke, Royal Academy of Engineering Chair in Systems Integration, for directing the centre for the past 5 years. So I do hope that you enjoy the morning, and now I will hand over to Jennifer, who will introduce the day.
Thanks, Nick. So welcome again. This is our celebration of 10 years of the Centre for Systems Engineering and Innovation at Imperial College London. In these 10 years, we've gained international recognition, building capability for and promoting the uptake of systems approaches in construction and infrastructure. Systems approaches are useful across operations, delivery, and long-term adaptation of infrastructure. So 3 questions for us this morning. First, how can we better operate infrastructure systems? Second, how can we better intervene and build infrastructure? Third, how can we make infrastructure adaptable over the longer term? We see ourselves in the centre as part of a movement for change in the way that we understand infrastructure, with systems approaches now championed in the work of the Royal Academy of Engineering, on safer complex systems, on sustainable living places, on decarbonising construction, and on net zero. The Institution of Civil Engineers, which is currently having a review of systems approaches in infrastructure, and also the National Infrastructure Commission, and through CDBB, the Digital Framework Task Group on flourishing systems. At Imperial, we bring a particular focus on systems modelling to work across engineering disciplines and systems interfaces in operation, delivery, and adaptation. In 2010, the Centre for Systems Engineering and Innovation was founded through a partnership between Lang O'Rourke and Imperial College London. Ray O'Rourke and our rector at the time, Sir Robert Keith O'Nyans, signed the agreement. Professor David Fisk became the director of the newly founded centre. In 2011, the centre launched a Masters in Systems Engineering and Innovation. The first Masters students joined Imperial College. The cohort included people who now work as technical managers in Lang O'Rourke. In 2012, the centre director, Professor David Fisk, was elected as president of the Chartered Institute of Building Service Engineers. The second cohort of Masters students joined the programme, and the centre hosted a technical symposium on building systems and services in the 21st century. In 2013, many of my colleagues were collaborating with Lang O'Rourke. Dr. Robert Vollum on construction joints, with John Paul Vella joining as a doctoral student, now a section engineer in Lang O'Rourke. Professor Washington Ochieng and Dr. Panayotis Angeloudis, who you'll hear from later this morning, were working on scheduling from the factory to the construction site for nuclear power. In 2014, we were joined by our 4th cohort on the master's programme. The work of the centre had impact with, for example, Professor David Fisk giving oral evidence to the House of Commons Select Committee on Energy and Climate Change. In 2015, I joined the centre. We were pleased to start a partnership with the Royal Academy of Engineering and Lang O'Rourke on systems integration. Professor David Fisk became an executive director of the centre. In 2016, as we became more research focused, Lang O'Rourke, Mott MacDonald, Bentley Systems and the Project Production Institute joined as members of the centre. Senior members of college and of industry joined for my inaugural, starting with the end in mind. And these included our infrastructure clients and delivery partners, so people like TfL, EDF Energy, Tideway, Network Rail, Heathrow and others. In 2017, we had our first industry showcase event at Imperial College London with keynotes, papers, posters. We supported our first projects, and many of those have gone on to win significant funding, external funding. We hosted a distinguished lecture from Professor Ray Levitt from Stanford University. In 2018, we had keynotes from Dame Judith Hackett, who you'll hear from later this morning on post-Grenfell building safety review of construction, and from David Hancock, the Infrastructure and Projects Authority in Treasury, our showcase event. We started Best Paper and Best Poster Awards. We co-founded the Transforming Construction Network Plus, a network of academics and industry partners bringing the research base with industry in transforming construction, working with our colleagues in UCL and Warwick Manufacturing Group. I gave evidence on off-site manufacturing for construction to the Lord's Science and Technology Committee inquiry. In 2019, we worked with companies including Lang O'Rourke, Mott MacDonald, Arup, Costain, WSP, TfL and others to run short courses on systems engineering leadership. And we were working also with UCRIC, University of Bristol and University of Twente. We hosted our annual showcase at the Institution of Civil Engineers with keynotes from major infrastructure clients, Heathrow Airport and Network Rail. And I joined the board of Construction Leadership Council. So to 2020, and today we have our online celebration of 10 years of the centre, and we're going to talk about some of our emerging research themes around complexity and resilience, systems integration, data-driven systems engineering, transforming construction, infrastructure life cycles, and carbon neutral to net zero pollution. We will launch a report in October 2020, but I hope today you'll enjoy our celebration and our emerging research themes. I'm going to hand over to Professor David Gann for our opening session. Thank you.
Well, good morning. Thank you, Jennifer. I'm delighted to be part of this celebration of the 10-year work of this great centre. And my name's David Gann. I'm the chairman of the UK Atomic Energy Authority. As you can see in my backdrop, I have two wonderful panelists and collaborators and guests with me. Ray O'Rourke, long-term friend and collaborator. Good morning, Ray. And Nadim Zahawi, our construction minister, who, if you didn't know, also knows a thing or two about business and digital business. And Nadim was a co-founder of YouGov and is a chemical engineer. And I'm sure being a part of the chemical engineering industry, Nadim, you'll appreciate the systems side of what this centre has been doing. You can see in the picture behind me an image from the hottest place in the universe. This is the inside of the fusion experimental reactor in Culham, South Oxfordshire. It has just broken records for its performance in creating a plasma. It runs at 150 million degrees Celsius, which is 10 times hotter than the center of the sun. And the UK is in the lead in developing the technology for fusion power, which when we get this working in a few years' time, will relieve the world of the carbon emissions and pollution that we currently create in producing energy. We will not be able to build technologies like this without systems engineering, without infrastructure, and without construction companies like Laing O'Rourke, which have so generously sponsored the centre, and which is the lead player in constructing the Hinkley Point nuclear reactor, Hinkley Point C at the moment. And in this country, we need to create the next generation of technologies. We need to create the skills, and we need to create the capabilities to plug all of this together to make the world a better place. Just by way of introduction, I thought I'd ask you to do a thought experiment and cast your minds back, not 10 years ago when the centre started, but 20 years ago. Now that seems an awfully long time ago. You know, at the beginning of the noughties, there was a lot of hubbub about creating a better construction industry. We'd only recently had the Rethinking Construction report from Sir John Egan, some of us, Jennifer White, myself, and others, Ray, particularly leaders in thinking about that. And we were in the middle of constructing Terminal 5 at Heathrow Airport. And I'm not sure that any of us realized what an iconic and important project that was to be, because it reset our understanding of how the industry could manage risk whilst also innovating. And it also set the industry to look outside of itself, to capture lessons from elsewhere, to think what is best in class, not just in construction around the world, but in other industries, aerospace, oil and gas. Nadim, we spent quite a lot of time looking at the North Sea offshore prefabrication capabilities back in the early noughties. And it was at a time when, Ray, you were really building a fantastic capability for your business. Channel Tunnel Rail Link was completed in 2003, and I think it was March 2008 that Terminal 5 opened. And so the noughties were a time when we tried to put into practice new principles, and we had digital toolkits. We talked about integrating the team. We wanted to have clients who showed the intelligence and thought to procure in new ways, to collaborate, to bring in the constructor and the team early. And we felt very much that the industry was moving forward, and indeed BIM, building information modeling and so on, was starting to take shape in its early guise. Bear in mind that for most of this time, the smartphone hadn't been invented. And then quickly coming up 10 years ago, 2010, when the centre was formed, we were just coming out of that awful recession from the financial crisis. And some companies, and Laing O'Rourke particularly, had stood firm with its investments in new technology, its factory, its R&D, and could see that we needed to create modern methods of construction for this country and around the world, in Australia, in the Middle East, and so on. And recovering from the financial crisis, we had this tremendous opportunity, didn't we, with the Olympics 2012. And I remember that huge excitement, because a deadline's a deadline when you're running the Olympics. You have to open on time. And the industry turned its capabilities, learning from those wonderful projects from the previous decade, actually, with many of the teams shifting across, and delivered what was a fabulous set of facilities and a great Olympics in 2012. And then we had this most enormous upswing and capabilities until the dreadful moment that COVID has knocked much of this on the head at the moment. And I think just to finish my introduction on COVID, it has masked some of the important questions that Jennifer just raised in her introduction. We need to keep our focus on climate, energy systems and the environment, particularly in our infrastructure and buildings and in the materials that we use. We need to learn more about artificial intelligence, machine learning and automation. These technologies are actually helping us through the current wave of changes that we're experiencing forced upon us by COVID-19. And we can harness some of those technologies to better effect, particularly in this industry, the use of data, digital modeling, the use of automation and so on in augmented reality in the way in which we design and produce our buildings. So looking to the future, I'm very excited about what the next 10 years will hold. And I think Imperial College with the Langer Centre, Royal Academy of Engineering, Jennifer White's leadership and the great teams that work across the disciplines on these subjects will be able to help reshape the future of systems engineering and the people coming out to work in that industry. Imperial won't do it on its own, and I was really pleased early on to see the collaboration with Stanford, with the sci-fi group there, and others, of course, around the world. Indeed, Jennifer has been working in Singapore and Hong Kong, and there's been a lot of ferment and exchange of ideas. So that, I hope, sets the scene. And I would like to hand across, first of all, to Ray. Ray, you hardly need an introduction. I've given you a little bit because I think you are the beacon as the champion of technology and innovation and delivering in a better way superior quality buildings and facilities. Would you like to share a few thoughts with us, Ray, please?
Well, thank you, David, and good morning to everybody. I don't know how well I'm known. It doesn't matter really. It depends more on what we do than who we are or what we talk about, because you have to evidence what you believe in. You mentioned a couple of things going through there, which I think are very, very important, and I think they're waypoints from my mind, anyway, my experience. So John Egan did a great piece of work. When he joined BA, he transformed it. He took learning from a parallel industry where he led Jaguar Land Rover. Well, no, it was Jaguar then. It became Jaguar Land Rover later. And he actually instilled a number of things that I think are pertinent today. And I am going on to something with the government piece of work later on this evening where we're talking about this project speed and doing things faster. What a lot of people don't realize is that T5, Terminal 5 was delivered and it didn't have a contract. It had an agreement. It was on 2 pages. So it didn't have all of the stuff that bogs us down today. And I think that's a vote of confidence that if you're going to do this stuff, you have to work with people that you trust. And that was the first thing that I would call out. The second piece is that our industry is massively disrespected and is bad-mouthed. And usually the disrespect comes from the adversarial nature of how our business operates, our industry operates. And of course, if you set up for failure, that's what you're going to get. Now, if we go back to the other big key point that you talked about, which was the Olympics. When the Olympics were won by London, I remember the excitement and also the consternation. We had then a chairman who said that the project was already 2 years late. Now, obviously, that wasn't the case because we came together and we were Langer part of it with Mace and with CH2M Hill. And we determined a number of things. One was that we didn't need to go outside the UK necessarily to get the project delivered. And it was delivered a year ahead of schedule. We actually babysat it for 12 months. And we turned to the Chancellor £1 billion. So there was another piece of evidence that I believe underpins what I'm now going to say. And that is now when we come to this particular inflection point we have, and the government is talking about what it wants to do under the auspices of Project Speed. I think speed is the key word here. We can't do the old-fashioned stuff in a new way unless something changes. And yesterday I had the great pleasure of visiting Hinkley Point and walking around what's going on there. And what I can say from our perspective, and I'll say this to a very wide audience, that project will not be late from the package of work that we're doing. However, it is complex. And I don't think our industry has engaged sufficiently with technology to underpin its delivery to the extent that it could. That then leads to another point you called out, which is 2050. I don't think 2050 is a sustainable date. I don't think it's credible. I think we have to move before 2050. Now, I would say that because there's a high probability I'm not going to be here at that juncture. But anyway, that's a different point. I believe that that's going to move in. And for that to move in, we're going to have more of this type of energy produced. And if we can get to repeatability, which is to actually replicate what you have done once. And we see that at Hinkley, the shift in productivity from doing Nuclear Island 1 with Nuclear Island 2 is just beyond imaginable. And it's no good talking in percentage terms. The quality, the flow of information, and how we go about that work. So I am excited by the future, but the future will rest with those organizations who invest in the technology. It's not optional. We just have to keep investing with it. And that is one of the things that we're blessed, David, having working with you at Imperial and working with Imperial in general, that we could actually engage and get to understand a little bit of that. And before I wrap up my words, on a scale of 0 to 10, some days we believe we're at 4.5, and on a very, very good day, we're just about 5.5. So we've got a lot of headroom to go and a lot of opportunity to really, really turn this country, this great country, into a leader in the world of delivering in our sector. And it has to get respect. And just to finish off, it is interesting when we look at who was on the front line in this current pandemic. I'm not going to call out other professions, but I will call out ours. So apart from the nurses, the doctors, the paramedics and support, it is our industry, the engineers that kept it going. And we need more respect, because in the hierarchy, in my mind, you have educators, medicators, and then you have engineering. And I'm being provocative here deliberately, because it's about time our profession was respected and seen for what it's done, rather than kicked around and treated as a second-hand or third-rate profession to be in. David, they're my opening remarks.
Thank you, Ray. Thank you very much for that, and for inspiring us to bring that timeline in and move fast with credibility and respect. Nadim, could I ask you to share a few thoughts with us, please? You've been in government in an extraordinary time, seeing industry have to shut down in an enforced way, and now trying to help it open up again, led, I'm very pleased to say, with a strong belief and investment in infrastructure and housing that we desperately need. What are your thoughts, please?
Thank you, David, and thank you, Ray. I would agree with everything you said, Ray, and we need more engineers in Parliament, but also in government, because I think, as you quite rightly pointed out, whether it's Hinkley or other infrastructure projects, the more engineering minds and people who understand systems in government, I think the better the outcomes would be. I am delighted to have this opportunity to speak to all of you as part of the 10th anniversary celebrations, David, of the Centre for Systems Engineering and Innovation. We heard a little bit from Jennifer about the sort of the history since its foundation by Prince Albert. Imperial, of course, has made a tremendous contribution to science and technology, and of course received global recognition for its scientific achievements, not least now in the race for a vaccine for COVID-19 with the Imperial team right in there. The centre is, I think, an example of what Imperial College does best, a combination of deep understanding of relevant technology, but a wider appreciation of its role and function within society and how it can best be used. During the past decade, the centre has made it, enormous, in my view, contribution to our understanding of infrastructure as a system of systems and how we can conceptualize and manage it in that way to deliver better outcomes for everyone. I set out in the Prime Minister's speech last Monday, and again, you will hear more of it tomorrow by the Chancellor. Construction is going to be critical over the next few years. We as a government are committed to a vision for an economic recovery that sees us build back better, build back greener, and build back faster, to Ray's point on speed. What does that mean? It means changing how we plan, how we design, and of course, how we deliver new infrastructure, how we deliver home, and of course, the social infrastructure that we so badly need, new schools, new hospitals. Realizing this vision will, I believe, require a bold new approach. I love the idea of Ray's Terminal 5 example. We need to design and construct buildings that are more energy and heat efficient. Some of you would have caught this morning's media around the Secretary of State for Business, Energy and Industrial Strategy. It's talking about the £3 billion that will be announced tomorrow by the Chancellor. $1 billion on making government buildings more efficient, but also $2 billion for people's homes to be made more efficient. And of course, then construct buildings that are more sustainable in material and promote biodiversity. They will need to be digitally connected. We know that. We've seen the power. Well, we are experiencing it right now in this platform of being digitally connected, capable of improvement and adaptation, and of course, for the components to be reused and recycled at the end of their life cycle. We also need to think more ambitiously, I think, about the role of buildings and infrastructure in society, their place within energy networks and their interaction with systems such as transport and utilities. They are not discrete entities, but part of an urban ecosystem in which we live and work. I think such a new approach is going to be absolutely critical if we are to achieve our legislative commitment to become a net zero nation by 2050, and some, rightly so, like Ray and other industries, challenge us that we will have to bring that forward. It is the law of the land that we get to net zero by 2050, and when it does become law, and I've spent many years of my life observing human behavior when I set up YouGov, then the whole machine of government, every department, every individual begins to focus on delivering on that law of the land rather than just a target. The technologies that are needed to deliver this vision already exist, and digital and offsite manufacturing technologies are at the heart, I believe, of transforming construction and the transforming construction challenge. This is across the Construction Innovation Hub, the R&D and demonstrator projects we are supporting, or the Network Plus academic research program that the Centre is helping to deliver. But delivering them will require us to collaborate, not just across government. That's incredibly important that we have a collaboration across government, but also across industry and academia. That is why I am absolutely certain that centres like this are absolutely vital in that journey. The importance of having Imperial, one of the very best universities in the world, focusing on driving systems engineering forward cannot be underestimated. I am particularly interested, of course, today to hear about your emerging research themes and how they can help us get UK construction and UK economy to where we want it to be. I will stop there and really look forward to the discussion now.
Thank you, Nadim. I realise that you've set out a bold agenda here, and Ray gave us some wonderful thoughts and objectives in how we should proceed with a sobering scorecard of 4.5 or 5.5 out of 10, depending on where we feel at the time. We're almost, for this session, the opening session, out of time, but I think in the spirit of being a panel, I should just ask 2 very brief questions, one to each of you. And perhaps Nadim, as you've just been speaking, I should ask you first. We've got industry that's up for it. We've got a university sector with Imperial and others who really are developing the talent and the technologies and want to work with industry. Government is up for it. What one more thing could we do? And to seed the thought, you mentioned collaborate. Perhaps we could see some beacon projects to demonstrate the art of the possible that government can inspire up and down the country. Is that something we might see in your agenda?
Certainly, and I also think it's worth us looking to the Construction Leadership Council. The CLC actually have produced a really good industry recovery plan, which is about restarting, resetting, and then reinventing and transforming construction. So, within the 650 billion of projects between sort of the now and 2025. In infrastructure that we will basically deliver or launch by 2025, there will be areas where I think the sort of work that you are engaging in will be absolutely critical. So I think the importance of systems engineering and the benefits of systems approaches are going to be critical. I like Ray was at Hinkley Point before the COVID crisis hit, because I'm also the nuclear minister, and I agree with Ray. One, I think that project will be delivered on time, but I also think that there are learnings from that, as he quite rightly pointed us to Nuclear Island 1 versus Nuclear Island 2, and what can we do to learn from that. As we deliver the energy white paper in the autumn. So a lot of really exciting things happening, but systems engineering is going to be absolutely critical. So I guess my message to you is, do you have the resource capability to scale up?
Thank you, Nadim. And I think the answer is we're ready to scale up. And I'll turn to the last word to Ray. Ray, with all your experience and wisdom and knowledge of the industry, if I could ask you to wave your magic wand across us, what one thing would you leave us with as a message to really get on with right now?
We have to change the way we procure our work, our projects. Procurement has to change. We have to trust, and there is a way of streamlining this. It has to become an incentive-driven, high-performance industry, and it can only do that by taking out all of the impediments we have and the adversarial nature of how we engage. And I'll come back to it. T5 was delivered of a framework agreement. It was a T5 agreement. We can do it. We have to trust each other. And there is integrity. There's wonderful integrity in this country. We see the way it plays out in this crisis. And that is the way we will change. And then from the universities and the academia, we have to really encourage young people to engage with the sciences, because it's the most exciting place for people to be. It's just so rewarding.
Thank you, Ray. Minister Ray O'Rourke, thank you very much for opening this first session of the celebration of the Centre. I'm going to hand back to Jennifer White. And just to, as a segue, Minister, you mentioned Construction Leadership Council, and of course, Jennifer White is a member of that. And I'm hoping that some of the ideas of how we connect across all the membership and bring the industry together will come up during the day. So thank you very much for joining us today and for all the support that you give the work of the Centre. Over to you, Jennifer.
Thanks, David, and my thanks also to Ray O'Rourke and to the Minister, Nadeem Zahawi. A very interesting discussion. I'm now going to hand over to the founding director of the Centre, Professor David Fisk, who will chair our second session.
Hi, everybody. It's a great pleasure to run this session, which is about complexity and resilience. I'm joined by Professor Washington Oching, who is head of our Transport Centre here at Imperial, and by Panagiotis Angeloudis, who runs the Transport Systems and Logistics Lab. It's hard to imagine a more dramatic backdrop to a discussion about resilience than living in a world pandemic crisis. As it happens, about a month ago, the National Infrastructure Commission, I'm a commissioner, issued a report on what we could do to improve the UK's resilience. And our lead recommendation was to say that government should set resilience standards. It makes good sense because once you have those standards for your main utilities, the rest of us can work out how we can handle all the disruptions that might well occur. The consequence of that, of course, is that the people who operate these utilities are going to have to run stress tests to make sure that they've invested in a way which can meet those resilience standards. And there is the problem, or the challenge. The challenge is that everyone agrees that our current systems have become more complex. How on earth do you do your testing when your system is a complex system? I personally quite like the idea that's often used in mathematics of defining your complexity by the amount of a system description that you just can't reduce anymore by simplicities like repeating or symmetries and so on. And if it's a really complex system, it's quite hard to guess what on earth it will do if it's moving outside your normal sphere of influence and experience. Therefore, we in research have tended to use new methods to look for hidden patterns in those complexity systems to see if we can improve our understanding of what is likely to happen. That's all a challenge. It's one that I think I'd like to turn to Washington to say a little bit about how he's looking at the transport's resilience issues. Washington, over to you.
Well, thank you very much, David, and many thanks to all joining us from different parts of the world to celebrate with us the first 10 years of the Centre for Systems Engineering and Innovation. Currently, I serve at Imperial as the head of the Centre for Transport Studies within the Department of Civil and Environmental Engineering. My background is in space-based safety and security critical infrastructure and their application for positioning, navigation and timing, air traffic management, and intelligent transport systems. Now, starting with transport, I would say that transport infrastructure is already very complex. I mean, think about intermodality, for example. And in my view, this becomes hyper complex when we consider other factors, including interdependencies the impact of automation and digitalization, electrification, and user centricity. Now, the point on user centricity is very interesting to me because it highlights the paramount need for connectivity within and amongst relevant infrastructure systems to deliver societal services such as capacity of networks, but without compromising safety, security, the environment, and of course, affordability. Now, this increasing complexity, together with the need to account for both conventional events that damage them, such as natural disasters and terrorism, we must now also consider, as already been mentioned before, pandemics such as COVID-19 and how infrastructure can be designed or retrofitted to be anti-fragile, able to absorb different types of shocks. Now, this is a challenge I feel as we have never seen before, and therefore requires, in my opinion, a fundamental rethink, both in understanding complexity and resilience. Now, this is very much in line with the hyper-complexity that is being brought about by the increasing merger facilitated by advancement in technology, such as AI, IoT, Internet of Things, and so on, of the physical, the digital, and biological in a human-centric world. Now, I believe that to address the issues of complexity and resilience that arise from this fairly complex interaction of many variables, we need advanced modeling and parameterizing tools that are able to represent infrastructure both in a synthetic and real way, how the different infrastructure systems actually do collaborate together to deliver public services. Now, in addition to those particular tools, we need also advanced risk assessment and management tools to enable us to look at vulnerabilities, how you exploit vulnerabilities, and so on, threats and therefore risks, and also how we can plan for their mitigation. And just finally, I think that for those tools to be successful, we must be inclusive in identifying all of the stakeholders, including members of the society, and to work with them to determine what society requires, specify those standards you mentioned, David, including ways of testing and validation of very low percentile risk events, which are not necessarily demonstrable in real life, and calling for advanced analyses. I also believe that the tools should be open to experts and other stakeholders for constructive appraisal and collaborative development. And above all, I feel that we also need as engineers to be honest about limitations, uncertainties, and how they propagate within those tools. Now, I have been involved with Jennifer, and before that, David, with the CSI to research on these tools, and we will continue to be able to develop those tools that have been mentioned in the previous session that will facilitate very quick, reliable delivery of infrastructure. Thank you, David.
Thank you very much, Washington. That's a list of challenges, isn't it? Panagiotis, would you like to add some points?
Thank you for this, David. We have indeed been working together in the field of infrastructure resilience for the last 15 years. And much of this work has evolved together with CSEI and the work that is carried out by the Transport Systems and Logistics Laboratory within the department. Our first excursion in this topic focused on a very simple question. How would the London Underground network cope under the potential threat of a coordinated attack? And also, what would it take to deliver a lasting blow in the operations of that network? We conceived and worked together on this question back in 2004 and completed the study just before June 2005. And we could say that this research was quite timely at the time, given events that happened soon afterwards. Our analysis indicated that the underground network had a structure that rendered it remarkably resilient and that a long-term disruption would have been very difficult to deliver. Long before data science was in the public conscience and in the headlines on a daily basis, we carried out this analysis using techniques that were borrowed from the field of complex networks and statistical mechanics. So what today would describe as network analytics. And this work spawned a research program that continues within CACI to this day. In our original study, we looked at a single civil infrastructure system, namely underground rail. We did realize, however, that it would be particularly limited to treat that network in isolation. Even if London Underground was disrupted, all would not be lost for London, since that is only part of a much more comprehensive transportation network with many alternative travel options and possible modes of travel. Studying a network like this in isolation would also preclude the consideration of milder forms of disruption, which however would be more likely to occur and could deliver much more, have a greater impact than extreme events. What would have happened, for instance, if there was a power failure that took out signaling systems across a wide section of the network? Such concerns led to a much more comprehensive network of our resilience model, which was built around the principles of systems modeling and incorporated aspects of response and repair. Case study on London's metro and electric power networks that was completed between around 2015 showed how the proposed methodology could be used to assess the potential impact of a local flooding incident that would disrupt the power grid and ultimately the underground. Using this generic framework, we're able to venture out to a much more diverse range of interdependent infrastructure systems. In a paper that we published in 2018, we studied the resilience of the global maritime network, specifically looking at container shipping. Individual transportation links are less of an issue in such a network, and instead we focused on the ability of individual ports to handle incoming vessels, and also the financial state and the ability of large shipping lines to function. Large failures are not unheard of in that industry, and they can have major effects in global trade for months after the event takes place. Reflecting on the unprecedented nature of the COVID pandemic, a pressing question these days is whether we could use such models to predict disruptions that are completely unknown to us. I think that this is possible and achievable through careful modeling. When developing such models, it is important to separate the nature of a disruption from its effects. Furthermore, using algorithmically generated scenario trees, we can exhaustively probe the ability of a system to withstand capacity alterations and therefore identify where the limits lie. This is the research that we're currently undertaking in our group and hope to test it soon against COVID-related applications.
Well, thank you very much. I'm always going to say that's reassuring, but isn't that always a danger with our research, that we tell everyone this is how we're going to do it, it's going to be safer, so everyone relaxes, and then something goes wrong? Would that be your experience or just mine?
We are working on it. I'm not saying that we have proved how we can make it safer, but the important thing is that we are identifying the problem and we're developing solutions for it. And this is what engineering is about.
Right. Okay. One of the things I was very curious to ask about really was many of the very big systems we're talking about exist right throughout the whole world, so they're not a local resilience complexity problem. Where you go into a major metro system, and for example, in lots of parts of the world, they're going to have very similar issues. Do you think that there's enough interplay between the various urban centres, for example, for getting a knowledge of resilience experience?
I would say, David, that we don't have enough. I mean, the point I was making earlier about collaboration is one that is paramount, I feel. We also have to ensure, I feel, that we put the society at the heart of our infrastructure acquisition processes. After all, it is for them. And I feel that this is not adequate at this stage. So stakeholder identification and stakeholders, particularly the society underpinning the entire acquisition process, is something that we need to very much encourage.
Yeah, because I've sometimes worried that when one looks at a case study of something that's gone badly wrong, very often you discover that the real details of what went wrong never really get shared. And I do hope that that these aren't just locked away from people looking after their personal their personal patents or whatever they want to protect. It is that very often when software goes astray, we're just told it's been fixed, but other people providing very similar software still have no idea what really caused that problem. So I'm rather hoping that, as you've described it, Imperial's program, which has a lot of international contacts, I think is going to be a very valuable input into this whole field. I'm just going to ask Washington, Panjabic, would you like to make just one or two quick, very final remarks?
I would say, Washington, David, I would say that we can only protect what we know. It's very difficult to protect what we don't know. And I think that we should spend a bit more time trying to understand vulnerabilities of our infrastructure.
Right.
Then we can come up with ways of protecting maximally.
I would add that modeling can play a big role in preparing us for the unprecedented events. How also modeling is not only the answer. So there need many organizations, particularly in the COVID pandemic, made disaster plans and dry runs of major disruptions that even though they had not predicted the exact nature of the event that took place, helped them a lot considerably to develop plans and learn from mistakes and identify bottlenecks in the response. So modeling is one part of the answer, but also good planning and good preparedness can go a long way in preparing us for the unknown.
That sounds great. Jennifer, I think I'm turning over to you. Yeah.
Thanks to Professor David Fisk and also to Professor Washington Angelidis and Dr. Panagiotis Angelidis. I hand over now to my mentor, Professor Karen Hallford, who will chair our third session.
Hello, Jennifer. Can you hear me?
Yes, hi.
I unmuted myself at the same time as somebody muted me, so that went a bit wrong. But anyway, it's my absolute pleasure to welcome everybody to this session on systems integration. I'll introduce myself first. So my name's Karen Hallford, as Jennifer said. I'm the Deputy Vice Chancellor at Cardiff University. I'm a mechanical engineer by background, and I'm also chair of the Royal Academy of Engineering Research Committee. I'm very pleased and proud to be your mentor, Jennifer, under the Academy's Research Chair scheme. So it's really interesting for me to be discussing systems integration today for a number of reasons, but the biggest one for me, I guess, is because in my role at the university, I'm overseeing a £200 million construction project. And so I can really appreciate the advances that you and your team are proposing and how they can benefit the construction industry. And for me, I'd like to think that by 2030, these advances can just be business as usual, and we can be reaping the benefits of these. So we have two fantastic speakers today, and we'll be taking the form of a panel session with some questions. So I'd like to hand over to introduce Jennifer White, obviously from Imperial, and Chris Millard from Laing O'Rourke. And I'll hand over to the both of you, Jennifer first, to introduce yourselves and a little bit about what you do.
Thanks, Karen. So as the context for this session, I hold the Royal Academy of Engineering and Laing O'Rourke Chair in Systems Integration. And I'm privileged to work with a team of outstanding researchers at Imperial. And together we've been bringing together disciplines and developing new technologies and methods, addressing the question, how do we coordinate across disciplines to achieve reliable, robust, safe engineering systems? So we're motivated by a tradition of thinking about systems engineering, and there's been work in our department, and I think Paul Jowett is on the call, who the department founded the Journal for Civil and Environmental Engineering Systems. There's been work on creating systems that work in the Royal Academy of Engineering that motivated how I started the chair. And there's been work by David Blockley and Patrick Godfrey on doing it differently. The systems integration is still a problem on today's projects, and it's getting more difficult with digital technologies used in delivery and embedded in our infrastructure. And so, and it's becoming more important with offsite strategies, design configurators, and component-based approaches to design and delivery. And so I've very much enjoyed our collaboration and partnership with Laing O'Rourke on the chair. My initial conversations with engineers across the business, visits to Explore Industrial Park in Steatley and Crown House Manufacturing in Aldbury, supporting their annual graduate development programme and cadets, PhDs in research and innovation, inputs on their work on small modular reactor projects, advice shaping their research agendas, working with Adam Locke and others. And my team have been working with Laing O'Rourke on the White City campus, construction progress monitoring, facades team on systems integration, requirements, product platforms, courses that we've run. And the collaboration has enabled me to build a sizable research team around the investment, significantly leveraging it.
Great, thank you, Jennifer. Shall I hand over to Chris now to introduce yourself and your work?
Oh, thank you very much, Karen, and good morning, everybody, and thank you for taking the time to join our celebration, which we're rightfully all very proud of, the last 10 years. For myself, I spent the first 20 years of my career in the automotive industry, both in leadership of product development and in manufacturing operations. And as everybody grows the skills they use in the rest of their career, in the first 10 or 15 of them, I guess, systems engineering, therefore, is embedded in my own personal DNA. And it was great to be part of what remains my old company, Jaguar Land Rover, a very vibrant part of our industrial capabilities in this country. I joined the construction industry to actually lead the engineering program on Terminal 5, where I was head of engineering, also led the digital development on how we use digital tools to develop the terminal, and took overall responsibility for the systems and systems assurance and integration of them. So very much pioneered the integration or the development of systems engineering in that program. Since then, it's been great to have the opportunity to be part of some great construction businesses and programs, and I now work for Laing O'Rourke, as I have the last 5 years, and it is a privilege to lead our research and development activity, which covers our design for manufacturing assembly approach across the business, and develops our new product sites, and continue to look about how we can push the boundaries of bringing high technology manufacturing solutions in an off-site way to drive site productivity and certainty in delivery. So have a great job.
Great, thanks very much, Chris. Now I'm going to ask the question now, which may seem an obvious question, but I think it's the question I asked Jennifer when we first met up to chat about your work. And so the question is, tell me, what in your view is systems integration in the context of construction?
So systems integration is the set of activities that enable disciplines to work together. So bringing components together to deliver whole engineered systems that are robust, reliable and safe. And I would argue that's actually harder in construction than it is in aerospace and defence, where people sit together around the table for 7 years. In construction, we have many players who come in to the process and step out of the process, and so how we integrate across that process becomes really important. Clarifying responsibilities, defining and validating interfaces, managing change, designing for manufacture and assembly, designing for operations.
And I guess an important part of that is the storage and retrieval of documents and records, of course, because across a project of that nature, where people are working together not only in different disciplines, but in different companies and so on, with people moving on all the time, that must be a real challenge.
Yeah, in my research team, and I think Chris can talk to these topics too, but in my research team, we've done a lot of work on how digital technologies are changing the delivery of major projects. And we did some work a while back now with Crossrail, looking at how they manage change in large data sets, and working also with Airbus and CERN on that. Because all of those companies, all of those projects and companies have kind of challenges of big data sets, and data can really work for you. And we're looking at the ways we can develop tools and techniques, mobilizing data science to help you. But it can also be kind of overwhelming and difficult if you're not using it right.
Yeah.
Just to build on that, the first thing I think we have to do is recognise we've got systems in a construction programme that aren't just IT systems or isn't just a network. A structural system, the facade system, the envelope, the substructure, the interface of these and how they come together. So interesting systems integration, we first need to get back and understand what the systems are. As you rightly say, Jennifer, how do we define them, create the sort of early stage requirements, and those sorts of embedded systems engineering principles. So I think whilst aerospace and the like develop the capabilities, what's exciting in our industry is that maybe the language is different. So we need to just help our engineering teams, our construction teams, through a different language to provide to apply these principles that can simplify how we go about our complex projects.
Yeah, indeed. And Chris, thinking about the life cycle of a new building, what part of that life cycle do you think is the most critical for systems integration? Where does it go wrong?
Well, I think we probably all got, I certainly have, scars on our back of picking up projects towards the back end and having problems with, so we say, more traditional systems integration, things not working, big complex data solutions not working, getting buildings to work from heating, ventilating, air conditioning, building management systems, and all the things that can be challenging, but equally in use, and particularly the more complex of things we do, hospitals, for example, airports, airport terminals, in use is even more important than in construction, both in terms of operating cost and equally the requirement for resilience. You can't have hospital systems failures, you can't have airport systems failures, transport rail systems. So often it's that end where the issues manifest themselves, but we probably all know that the origins are much earlier, right at the start of the project and in the concept end. And I think the lesson that we can really take in the systems engineering world is remember the V diagram, the very simple expression of systems engineering, and at the top right, the definition of requirements, and getting right up front, understanding the requirements, definition of the systems that are engaged, how those systems are going to interface, and bringing through that the various validation and verification solutions and strategies that are embedded in systems engineering thinking. It means progressively, as you move through the project lifecycle, you're building that body of evidence that you don't hope that your systems will work or don't believe they will integrate. You know they will because you have the evidence to demonstrate it. So planning that right from the start of the project, from the concept design, where it be how we plan to commission, what systems, what systems talk to each other, how they will talk to each other, what the definition of the interfaces are, the asset management plan, the structure, the data sets it sits on, and then underpinning that, taking the digital data, how do we, right at the start, set out the plan for the use of that digital data to systematically build the capability throughout the project and harvest that as we go through, rather than rushing and putting it all together at the end. So right at the start is the answer, I think, Karen, and it just requires a fundamentally different approach to the way we plan a project.
Yeah, thank you, Chris. Jennifer, have you got any thoughts on that?
Yeah, I mean, just to emphasize what Chris is saying, my inaugural was called Starting with the End in Mind. Yeah, and we often think about systems integration as being, you know, the kind of final stages of the project, the testing, the commissioning, the handover. Yeah, and we've done a lot of empirical work looking at those stages. But actually, to get those stages right, there are things that we need to do differently right up front in the project. And that becomes all the more important, and there's more potential to do that as we start to move to offsite strategies. So we start to be able to build design configurators and platforms and understand the interfaces up front, right at the outset of project delivery, and to be able to deliver in a different way, the kind of way that Ray O'Rourke was talking about earlier.
I think, and I mean, just to extend this bit a little bit, I think we're talking about something that is quite new for the industry. And so how do we, probably this is for you, Chris, how do we win hearts and minds to make sure that people take that time at the beginning of a project to work in this way?
I think the key thing is to package it differently from, this isn't, you know, create the construction engineering version of systems engineering, which is a lot of what we've been doing through the centre at Imperial College, rather than expecting people just to take on board what's been done in other industries. I think, and a good example in part of my periods in leading construction businesses, I've applied lean technology and lean techniques from the automotive sector, for example. And I tried with some folk from one of the leading proponents of lean technology in the automotive sector. They joined. It was unsuccessful. And it was unsuccessful because they're used to working in an ecosystem where everybody else understands systems engineering. Everybody else gets it. There's an operating model in the business. And they never stood back and understood what the simple basics were that we need to start with in our industry. And actually, there are very few people I've found who can build that understanding of bringing the common sense of beginning with the end in mind into the construction sector. So I think it's how we asking the right questions at the right time, and they're very simple questions. And do you understand the scope? Do you understand the detail? How do things integrate? And what evidence have you got that that will work? Very simple questions that can help us begin to build upon the systems engineering principles, then call in the expertise from Jennifer's team and other areas to support the issues that emerge when you start to open up those simple questions.
Well, yeah, thank you, Chris. Okay, so I'm keeping an eye on the question and answers, but we don't have any. So I've got another one for you. And this is interesting because we're talking about modern methods of using you know, modern computing techniques and so on to facilitate this. But what about construction methods? You know, how can modern methods of construction integrate with the challenges of complex systems integration? I suppose that's for Chris first, or?
I can start on. Yeah, I can start on that one if you want. So I think modern methods of construction can help us address the challenges of complex systems integration. And you know, with my work on Construction Leadership Council and the Transforming Construction Industry Challenge, Project 13, you know, the kind of work that Farmer's doing. There's a lot of energy in the industry at the moment to look at how we use modern methods of construction. And I think they can support addressing systems integration challenges because they require you to take up a new way of working. They require you to think about interfaces up front in that process. I think there are new challenges, and you know, actually the challenges of working remotely and working on the same digital model, you know, are challenges that we're kind of engaged in at the moment, right? So I think the digital realm becomes part of that as we start to think about a digital twin for a project as well as a physical delivery. But if we can look at that in a more manufacturing type approach, certainly in terms of some of the components and systems that go into the building, that can really help us.
Yeah, thank you, Jennifer. And Chris, have you got any examples perhaps of where you're using modern construction methods in this way?
Yes, and building on that, repeatability and standardization is the key here. Ray mentioned it earlier in the Nuclear Island 1 to Nuclear Island 2. When you see Hinkley site, you've seen pictures of it, it is vast. You wouldn't believe how you could create so much learning and transform performance in a way, but even on a scale where you might think it's a one-off, you can, and it's looking at the repeatability and standardization of what we do, and that doesn't mean, making the point, doesn't mean everything's the same. It's about the standardization of the process, methodology, standardization of the technical principles or the engineering principles that are sound, connections, for example, and the way parts come together. So stepping back from that, a good example, we just recently, as probably you'll have seen in the press, completed a hospital in South Wales, in Cwmbran. It's the Grange University Hospital, and opened a year early. Opened a year early on the basis of we captured in that project the learning from Alderhay in Liverpool, from Dumfries and Galloway Hospital in Dumfries, and added through that then the kit of parts, if you like, that built it. So we used the kit of parts we use on many different buildings. There were some 9,000 different products delivered to that site, covering substructure, covering main structure, facade, the systems in the building, the bathroom and utility areas, all those things. And we know how they come together. We know how they come together in the value chain, the logistics supporting processes or whatever. And that enabled us to open that a year early to support the COVID crisis. And extending that now, we're now confident that that standardized kit of parts, if you like, we can now do a 600-bed hospital in just under 2 years, 98 weeks, which is about half the time previously. So yeah, huge opportunities here if we really embrace it.
That's incredible. We've got a question on the question and answer. So although we've only got 30 seconds, I'd like to answer it. I'd like you to answer it. So it's a question for Chris. You mentioned getting specifications right at the start in a changing world. What methods can you leverage to cope with changing requirements for a system?
Okay.
10 seconds.
The first one is having a proper approach to change management, and to very simply, one end, a spreadsheet requiring a list of changes, who's involved, making sure stakeholders are engaged and understand the impacts of that change, and a proper sign-off process. So managing that, I've done it on projects I've run in construction.
Perfect. Well, I'd like to bring this session to a close. Thank you both very much indeed for your thoughtful responses, and I'll hand over to the next session with haste. Thank you very much, both of you.
Thank you, Karen. Yeah. So my thanks to the Royal Academy of Engineering and to Laing O'Rourke for their support for the chair. I'm now going to hand over to my colleague, Professor Julie Mccown, who's going to host the final session before coffee. And hopefully she's on the panel list.
Thank you very much, Jennifer. It's a great pleasure to host this session on data-centric engineering today. I'll start my video, excuse me. I'm just concerned that we haven't got our team in today, so I can see one person. I think another person was trying to get on, Ivan's trying to get on. So hopefully behind the scenes, our Wizards of Oz will be able to sort that out in the meantime. Anyway, our session today is on data-centric engineering, and today we have an interdisciplinary team with Kate Simpson, who you can see online, who's from the Dyson School of Engineering Design. And Kate is also, like myself, she is a member of the Data-Centric Engineering Challenge or Programme of Work in the Alan Turing Institute. And our other person, hopefully when he gets online, is Ivan Stoyanov, sorry, and he's from the Department of Civil Engineering. And his area of work is on water systems engineering particularly. And he and I worked together in a project a few years ago, a large project sponsored by NEC Japan, looking specific at next generation water systems. And that was taking a very strong systems approach to look to see how we could make basically an internet of water. And he will talk about that hopefully later on. I'm Julie Mccown. I'm from the Department of Computing. And my area of research is in sensor networks, Internet of Things, and cyber physical systems. And I also, as I said, run the Critical Infrastructures Challenge within the DCE, the Data Centric Engineering in Turin, in the Turin Institute. Avans on, hurrah! Right. Okay, so what is data centric engineering? Well, we've heard earlier today about the amount of work that's happened in the past 10 years and beyond in the development of systems thinking with regards to construction and other industries, but also industries, for example, like our critical infrastructures, and also in other industries like car manufacturing and industries generally. Now, in parallel with that, we've started to see a confluence of technology developments that have helped to aid that situation. So, for example, we've had unprecedented use of sensor networks where the sensors themselves have become lower cost, far more reliable, and their span of ability has improved. And at the same time, we have improvements in low-powered communications and low-cost communication systems. And joined with that, we have the development of better analytical tools to better understand data. And that includes better statistical methods and machine learning techniques and so on. So bringing this all together means that we have this unprecedented level of spatial and temporal resolution to be able to better understand the systems under focus. And this allows us to be able to model these systems with a little bit more reliability, with much more knowledge. And this brings us to the potential in terms of the design, the maintenance, and the development of these systems in a much more resilient and indeed sustainable way. And so we can even take this further, where we can start to look at these systems as an online real-time system, whereby these data systems are feeding the models, the systems that we understand. And in doing so, we can start to get those systems to become gradually more autonomous, and we develop more control techniques beyond that. So our talk today, we hope that you will go away with 3 major points. Our 3 major points are to do with infrastructure, the projects themselves, and cyber-physical interaction. Okay, so the point with regards to infrastructure is the research and the challenges and the knowledge around how to better use data to inform systems engineering and decision making. With regards to projects themselves, we're looking at how we engineer complex projects, how we add the digital to the systems thinking, and how we look at model-based approaches to describe the products and the process of systems using machine learning and other mechanisms. And finally, the third point that I want you to go away with is this notion of cyber-physical interaction, which may be new to some of you. That is where we have some notions of real-time operation, we've got control, we've sensors driving the data analysis, and so on, and these systems interact. The computer system drives a lot of the system under focus, the physical system, and the physical system can actually impact on how well that digital system works. And this is the cyber-physical interaction. And so we want to look at how we can co-engineer these systems rather than develop them separately. So my personal work is on that latter topic, as you can imagine, being a computer scientist. But what I would like to do before we discuss some of these challenges is firstly hand over to Ivan. And maybe, Ivan, would you like to tell us more about how data-centric engineering impacts critical infrastructures such as water networks, for example?
Thank you, Julie. Good morning, everyone. Just to give you an introduction, my name is Yves Austrian. I'm a senior lecturer and EPSRC fellow in water systems engineering. I work on the design, optimization, and control for supply networks that dynamically adapt their connectivity, topology, hydraulic conditions, and operational objectives. And as Julie said, this is very much a new category of engineering, what we call cyber physical systems, that combine physical processes with computational control in a very holistic way. And in order to achieve this dynamic adaptability, the resilience, the efficiency, and the sustainability. So as part of this effort, I lead a 5-year program with Agri Water, Severn Trent Water, Bristol Water, United Utilities. These 4 water companies operate roughly about 39% of the water supply infrastructure in England and Wales. And apart from research, in 2015, I founded a technology spin-out, Informatics Limited. The company now offers advanced monitoring and control solutions for the water utilities in over 20 countries worldwide, and it has secured funding from leading investors such as Suez. I'm also an expert witness for the Grenfell Tower. I have been investigating the provision of adequate flow rates for the water supply network to allow London Fire Brigade to fight the fire. And I think as the reports are going to be published later this year, it's a good example how marginal system failures have led to some very significant and critical failures. And again, the only reason why we can get to such a detail of what happened of the night is because of the data we have managed to accumulate and gather through that event. And finally, I want to sort of put it into the concept of the pandemic now. COVID-19, together with a performance target imposed by Hallford to reduce leakage for the water industry, present significant challenges for these utilities. And I would say that just as an example how in a very how we applied our technologies during the COVID crisis is our monitoring and control systems have been deployed to improve the resilience of supply to Nightingale hospitals, for example, the Nightingale Hospital in Bristol. And this is just an example where, as one of the previous speakers from Lion Cruz mentioned, about the recognition we as civil engineers, as public health engineers, have actually played a role into this pandemic. So this is just a brief overview of what I do.
Many thanks, Ivan. Now, we know through trying to integrate data-centric approaches within engineering, there are many pain points. Kate, could you tell us more about this?
Yeah, hi. So hello, everyone. Great to be here with you for the virtual celebration. I'll start by giving a brief intro to myself as well, and then go into a little bit of detail. So as Julie said, I'm a postdoctoral research associate at Imperial College and also visiting researcher at the Alan Turing Institute. And I also work on the data-centric engineering program with Julie, funded by the Lloyd's Register Foundation. And while Ivan looks at managing water systems, my interest is in upgrading existing building infrastructure to avoid demolition and rebuild. And working at the National Institute for Data Science has taught me that this is much more than technical skills. It's also about ethics, collaboration, open working, and the process of managing data. The Institute is a great example of bringing together multiple disciplines with common interest of using data to benefit society. I'm part of both the Dyson School of Design Engineering and the Centre for Systems Engineering and Innovation. And I work closely with Jennifer White. And this is great because I see myself as both a creative and a whole system thinker. And my current research on the Design for Retrofit project brings together data science to answer questions on existing low-rise housing infrastructure, in particular how we reach net zero carbon in a safe way. For me, data can make the invisible visible. For example, with indoor air quality, building performance and energy demand to enable a whole building systems approach. And I work to address uncertainty in decision making, of which there can be much with existing buildings. And this combines at the moment for me bottom-up physics-based modelling and learning from samples of monitored data from buildings. And we can scale this up with probability techniques such as Bayesian analysis. And the opportunity to learn from real-time data, as we've already heard, is increasing, and computational capacity to deal with this is accelerating, as Julie mentioned. And both can help us learn what works well and what doesn't with building upgrades. And we can then inform similar projects and equip building professionals and stakeholders, including citizens, with the knowledge gained. I hope we can progress beyond reductionism in engineering and include wider parameters such as the indoor environment or impacts of product manufacturing as standard to minimize risks. I also run a small project mining patent data to explore technology innovation in the field and hope to learn how trends relate to policy change. And linking to Julie's research, I'm interested to explore the co-creation of data and systems to inform decision making. So I have another 3 points which I'm keen to discuss with attendees here today. I know that we have a few people who are also working in similar areas to me here. So one is, how can the built environment sector move towards more open data that we can learn from while respecting privacy and ethics? Number two is, what tools do teams like to use which go beyond operational energy and could be used in decision making for housing retrofit? I think we've come a long way with commercial buildings, but the housing retrofit is still a big challenge. And how do we better engage citizens and building professionals with data on energy use, indoor environment quality, and the impacts of choices that they make or the building managers make? Okay, thank you for listening, and look forward to the discussion.
Thank you very much, Kate. Okay, I would like to hand over to Ivan. A quick question with you. To pick up on one thing you just said was the ability to, in a very agile way, move to supporting the Nightingale Hospital in Bristol. How much of systems thinking allowed that to happen?
Well, it was very much, first of all, the way we approach this problem is to understand operation of the network. Clearly, one of the key challenges during the pandemic was the reduced workforce. And the data collection systems we developed and commercialized at Imperial provides the ability to gather spatial and temporal data with unique resolution. So just putting these systems in place and very quickly deploying our optimization methods allows us to almost reduce the probability of failure as a first instance. The second instance was allowing us to start controlling the system in a way that we can very quickly change connectivity, the topological connectivity of the network, the hydraulic conditions. So that will allow a very quick response to any forms of incidents within the network itself. So the issue there was the way we looked at the improvement of the resilience was several aspects. One is understanding what the system is doing almost in real time. The second one, having the ability to very quickly deploy incident management modeling tools, which allows us to optimize response. And the third one is optimizing control, which then allows us to build this additional redundancy in connectivity and supply, and at the same time make sure that the way this is redundancy and very advanced control systems are operating are not causing potential problems on the network itself.
Thanks very much.
And there was another aspect to that was the water quality as well. I mean, as we know,
okay.
Water quality, the optimization of chlorine residual as a public health is a very critical aspect. Utilities are monitoring water quality, the outlets of their treatment works, but very little is happening in terms of what's happening in the distribution network. So the ability, again, for us to optimize hydraulic conditions and water quality at the same time requires the deployment of some very advanced optimization methods. And this is where the beauty comes, that these optimization methods are not just some research kind of good idea done by some guy sitting at Imperial, but actually solving real problems.
Excellent. Thanks very much, Ivan. Kate, I wonder if you could discuss more about something you did mention, which was uncertainty in decision making. So how does data-driven systems or data-centric engineering help with that?
Yeah, this is a good question. So in existing building retrofit, there's multiple ways to think about uncertainty. It could be about the practical technologies that we use, the cost of deploying those technologies, but thinking about the data science, uncertainty commonly means probability theories and how we can reduce the uncertainty in modeling through calibration with measured and monitored data. So I'm working at that interface, bringing together what we know from modeled insight, which is what generates energy performance certificates, which we know there's many uncertainties with those. And as we move towards having more operational energy data, we can reduce this. But I also think we should not only look at that in our decision making, we should be looking at wider parameters as well as energy use.
Okay, thank you very much. Ivan, back to you. Now, there's this conversation about moving from looking at planning and using data for planning to the more real-time execution. And then there's this conversation about moving forward to autonomy. I mean, what do you think the main challenge is there? And can you imagine, for example, a full water network being fully autonomous?
Well, I do imagine it. I don't know whether other people imagine it, but I certainly do imagine this future. I think it's coming to a point where this is a very expensive capital infrastructure, so we have to make huge capital investments. And the fact is that we can offset a lot of this capital investment through better operational management and control. And this is where the trade-off is to, and the technologies we have in terms of near real-time monitoring, near real-time control, particularly in water supply networks, and the optimization methods we have been working on, allows that kind of optimal integration to start thinking not just about huge capital projects, but how to make the most use of the current infrastructure.
Mm-hmm. And there is a big conversation around trust as well. When we add this digital system into the systems of systems, we have to obviously trust it. So it has to be engineered at the same levels of resilience and so on. Kate, I wanted to bring that notion of trust up. Do you work on data ethics, or I mean, you're monitoring indoor environments. What's your feelings about that?
Yeah, I think when we're working in people's homes and monitoring data in people's homes, ethics is one of the most important questions. And this is why partly why we have a lack of open data around that. And we need to find ways to learn from samples of monitored data without being able to identify householders. And yeah, that's one of the big questions. And also how we openly share the tools that we use and allow input and collaboration with those. That's another ethical issue. If everything's a black box, then we cannot progress in the same way.
Marvelous,
just
thank
to
you.
flag in case you spotted it, there's a question from Alex in the chat as well, which we can come to.
Well, we're kind of out of time, but we do have our breakout discussions that are basically happening quite soon. So I would really suggest that, I imagine that we've brought up a number of challenges and questions today. Very happy to discuss these in our breakout sessions. And to this end, I've enjoyed our very quick session, and I've now hand back to Jennifer. Thank you for listening to us.
Thank you very much, Julie, and thank you to Kate and Ivan as well. So we're now moving into breakout sessions. I have to admit we've had some technical problems and we've been running behind the scenes to try and get those sorted for the breakout sessions. And what we're going to do is put some links into the chat for these 3 breakouts. I would suggest that in the breakout sessions you have your video on, but you mute when you're not speaking, and they're really to give you a bit more opportunity to interact and to talk to the panelists and to talk to each other. They will not be recorded, but we will take some notes. Please don't tweet in these breakouts. If we have some technical issues over coffee, then we will open these breakouts again at the end of the day. So please come back to the webinar at 10:50. We have a great session on transforming construction. We'll start promptly at 10:50. The link to the main webinar is also in the chat, and we will put it into the chat of the breakouts. See you soon. I'm going to give people a minute just to get back from the breakouts. And I know people were still in the middle of discussion in the breakout I was in, but I'm keen that they're here for this session. And I know people are rejoining.
Good. Are we all live then? Oh,
you're live, yes.
Yeah. Okay.
So.
Hi Luigi, hi Fergus.
Hi Sam, hi Luigi.
Should we start?
Yeah, so I think we should start. So welcome back, everyone. I hope you've had a good discussion in the breakout, and we'll run those breakouts again over lunch. So if you want to continue the discussion, then please do. I'm delighted to hand over to Dr. Luigi Mosca, who will chair this session on transforming construction.
Thank you, Jennifer, and good morning, everybody. I'm so pleased to welcome you all to this session, Restart, Reset, and Reinvent. I'm Luigi Mosca. I'm a research fellow here at the Center for System Engineering Innovation, and I'm also involved in the research program of the Transforming Construction Network Plus. That is one of the investment in the Transforming Construction Challenge. I think that today's session is really today's session and all our today's discussion is a very timely discussion. I think, as the minister mentioned before, the Construction Leadership Council recently published a roadmap to recovery, so an industry recovery plan for UK construction sector, and also, as we heard this morning, there are many opportunities for this sector, for our sector, to recover and to do better, to improve after the crisis. We have today two great speakers, and I'm going to hand over to them. We have Fergus Heritance, that is the Deputy Director for construction, and also Sam Stacey, who is leading the construction challenges at the UK era. I'm going to hand over to Fergus first. Please, could you introduce yourself?
Thank you, Luigi. I'm Fergus Heritance, and I'm the Deputy Director for Construction in the Department for Business Energy and Industrial Strategy. And my responsibilities are essentially to undertake work with a range of organisations in the public and private sectors to improve the productivity of the construction industry.
Thank you, Sam. You would like to spend a few words about yourself?
Yes, I'm Sam Stacey. I'm running the Transforming Construction programme. So this is part of the industrial strategy, and it's about using the 170 million of government support to transform the industry and really to approach it as a system, to tie in government procurement of buildings, the academic capability that we've got in the country, and then the wide range of industry players we've got that actually deliver construction projects. I was a student at Imperial myself, so I did a civil engineering degree in the 1990s. Great experience, and really one of the best places to study and understand engineering. And I say maybe to understand how engineering works and how we deliver value in a hard sense to society. Prior to that, I did a degree in architecture and philosophy at Cambridge University. And for me, it's been really valuable to get an understanding of the hard value of the built environment from Imperial, and I would say the cultural value of the built environment through my experience at Cambridge and studying architecture. And then throughout my career, I've worked in construction before my current role with UKRI as Innovation Director at Skanska, and really seeing firsthand how we've got these fantastic innovators in the construction industry, but the system doesn't work. The system is a blocker to innovation in the industry, and that's what's so fantastic about the Transforming Construction programme that we've got at the moment. Sorry, that's the police car going by. We're able to bring together these key elements, the clients, and especially the form of government, the capabilities of the industry, the suppliers, the rules and regulations around construction, and the skills contributing to the whole system. So that's me.
Thanks a lot. I mean, you mentioned innovation, and also a lot we were talking about sustainability. So I have a question for you both. What are the key metrics for assessing the performance of a sustainable and innovative construction sector?
Go on, Fergus.
You go first, Sam. That's fine.
Okay. Well, I mean, the simple fact is that we have to be aware of what everybody cares about with regards to construction. So there are some straightforward hard metrics that actually were, the first set were defined in about 2013 when the government and the Construction Leadership Council set out the 2025 construction strategy. So reduction in whole life costs, reduction in delivery time, reduction in the trade gap around construction, improvement in greenhouse gas emissions, and then a number of other metrics around productivity and the business case for adopting new technologies and take up of new technologies, particularly by the government sector procurement facilities.
Yeah, I agree with Sam about that. I think looking to the future, we need quite a wide range of metrics, some of which have got to address some of the big societal challenges we face, like climate change and the move towards net zero carbon, where we're looking at things like both on-site emissions, embedded carbon in the buildings and infrastructure that we produce, energy consumption, heat efficiency of the built assets that we actually produce. But we also need various metrics which consider industry performance. And as Sam says, an element of that has to be about innovation, the uptake of innovation, level of investment in R&D. But we also need to look at what skills the industry is investing in and to what level it's training its people. And we have to look at some of the other outcomes that we're looking to achieve in the Transform Construction Programme as well, around things like site safety and improved site operating procedures. And I think this is even more important in the context of COVID-19, given the potential risk that all workplaces become vectors, the transmission of the disease. And then finally, I think we need not to lose sight of the fact that ultimately we build assets of one type or another for a purpose, and that purpose is to underpin the efficiency of the operations of various services and organisations in the public and private sectors. And we need to make sure that we are capturing some metrics around that and comparing the efficiency with which systems, services, etc. are being delivered before and after we've adopted some of these innovations and new techniques, and also the satisfaction of users and the occupiers of buildings of different types as well.
It's interesting, and what I can understand here, there is a big role of the technology and collaboration. So just building up also my interest, how the new business model and digital platform can exactly enable stronger partnership across the whole construction ecosystem. What do you think?
Okay, so business models are really essential to the transformation, changing business models. And you know what we've all experienced in the industry is this fragmented approach where you've got layers of subcontracting, the sort of lowest common denominator at all levels, competitive tendering. And where we need to get to is common business models that are all directed at the same aims. Ray spoke a little bit about, and some others spoke about this earlier in the session. T5, fantastic example. A set of organizations coming together, having a trust amongst themselves and being able to work collectively to get the best outcomes. Now, there's various ways of doing that. You can have a properly vertically integrated company, and Laing O'Rourke is a good example of that, where you've got all the capabilities within one organization to act as a client, to design, deliver, operate the assets. Or alternatively, you can take what I would call virtual vertical integration, where you identify the aims for the project and the asset, and then you just make sure that all the players, all the stakeholders involved in the delivery have always got their sights set on achieving overall benefit, overall value for those assets. And that requires partnership arrangements. Project 13 by the ICE is a good model for that. And the other thing I would mention, so you've got vertical integration, virtual vertical integration, and then digital systems integration, whereby you've got a digital system that defines the rules by which you operate. And the Construction Innovation Hub, which is part of the Transforming Construction program, is doing a lot of work on platform design and associated digital systems integration, which should help, again, bring everyone together to play to their strength to achieve the outcomes that we need.
Mm. Yeah, I would endorse everything that Sam said. I mean, for me, this all really stems from the fact that we have, for really probably since the 1980s, had quite a reductivist approach in a lot of procurement exercises within the UK, and this is across both the public and private sectors, where we are focused very much on cost. And we take the view that the way in which you drive down costs and increase efficiency and value is through competition, which I think works to a certain extent. But the problem is when you have large, complex, high-risk sectors like the construction industry, there's a real risk that this flips over into promoting a very destructive form of competition that undermines not only profitability and the sustainability of firms within the industry, but actually the value and the quality of the built assets that the industry produced. And obviously the most egregious example of where this went wrong was the Grenfell Tower fire, but there are plenty of other examples where this destructive cycle of focusing very much on driving down costs has undermined the ability of the industry to deliver effectively. And what we really do need is a different approach, which we recognise within the public sector, is also adopted within the private sector, where we do promote a much higher level of collaboration and engagement, and where actually you try and make competition around the right things, which are value, innovation, the delivery of various social and environmental benefits as part of the bill. And you're actually rewarding firms that adopt not only a better business model that promotes collaboration and engagement with others, but the ones that actually behave responsibly in terms of their contractual and payment practices. And that's actually the kind of competition that you want to promote within the industry going forwards. We are starting to do some work on that in government, which is being led by Crown Commercial Services and the Infrastructure and Projects Authority. And it's also been something that the Construction Leadership Council has been doing for years through its Procuring for Value work stream. And that's now very much part of the Transforming Construction challenge that Sam is leading. So hopefully we are moving things in the right direction, and we're equipping people with some of the tools and mechanisms. But I still think there is a big challenge in the industry, which is actually changing the culture and the attitudes and the habits that have been ingrained over the past few decades. And that is probably the problem that we need to crack over the next 10 years.
Yeah, just a comment on the changing of the culture. You know, the concept of the tipping point is very relevant here. You know, what is it that achieves this shift from the current prevailing way of doing things to a new way of doing things? Now, part of the Transforming Construction program is to sponsor a set of demonstrator projects that show that there's a better way of doing things. And actually, we're already seeing some excellent results from that. There's a webinar next week run by the FT explaining 3 examples of that, one relating to housing, one relating to schools, and one relating to office blocks. So I think, you know, a major step on that journey is demonstrating that it really works in practice. And then I think the tipping point really is going to come when something like 15% of projects are procured and delivered in this way. And then at that point, everybody goes, oh, well, clearly there's a better way of doing things. Let's just move on, regard the old way as obsolete, and pile into the new approach, the more joined up approach to construction.
Yeah, thank you. Definitely, I'm sure you are doing both the right thing in the right direction. If you allow me, I would like to pick up a question from the chat that I can see here. We were talking about the social behavior also of the sector. What about the inclusion of affordable housing as a part of industrial strategy infrastructure program? What are your thoughts about this?
Sorry, housing as part of the program, did you say?
Portable housing, yes, yes.
Portable housing?
Yep.
I'm not sure. I'm not sure. I mean, portable.
Sorry, Sam, it was affordable housing.
Yeah, I'm sorry, affordable. I'm so sorry. I'm so sorry. Yes, the answer is well, the government doesn't directly procure housing, so we don't have quite the same influence. A big program that we're sponsoring is housing advanced methods for the creation of homes. And applying these techniques that we've talked about, so the industrialized techniques and the digital process and more value-based judgments in relation to housing. So I think this is something that will be very directly benefited and addressed by the program.
Yeah, I mean, all I would add to that is that I think the approach that's been adopted by Homes England over the last 2 or 3 years is going to do an awful lot to promote the uptake of off-site manufacturing technologies to deliver social and affordable housing needs, which is obviously one of the objectives that Homes England is set up to achieve. It has given itself the ability to support developments in a much larger range of ways than it's previously had, including through direct debt or equity funding of projects, joint ventures and firms, as well as being able to invest in enabling infrastructure projects that will enable developments to take place. So Sam is absolutely right to say that government doesn't undertake direct procurements of homes in the way that we do with schools. That might change in future, but that's certainly the statement that's true at the present time. But I think we are trying to work flexibly around this to enable us to use some of the new technologies and to support some of the more innovative businesses in this sector to deliver to meet the need that we have in the UK for not only housing numbers, but for a larger number of social and affordable homes as well.
Yeah, thank you. I would like to pick up a very last question because we have just a few seconds. In the supply chain should be driven the shift to the manufacture of our built environment?
Sorry, you're going to have to repeat.
From the supply chain perspective, we are going to drive the shift to the manufacturing approach.
I think pipeline, clarity of pipeline is a key thing here. In order to achieve the shift we want, the supply chain needs to invest in delivery capability. In order to do that, they need surety that they're going to get the throughput through their factories and their facilities. So with the clarity of pipeline and clarity on the rules and standardization of the products, that will pull through the investment and then the delivery capability from the supply chain.
Yes, I agree. I think that's absolutely right. The problem with the construction sector at the moment is that it is so influenced by the economic cycle, and that really does militate against investment by firms. And the government is as guilty as anyone else of doing this. We've tended to spend lots of money during boom periods, which have driven inflation in wage cost, material prices, etc. But then we've chronically underinvested in downturns, which has resulted in large-scale unemployment within the industry, lots of insolvencies, and actually older workers tending to leave the sector. So what we do need is a much more sustainable and longer term approach where you almost have a counter-cyclical investment strategy where you make sure that in bad times as well as good times, you are investing a certain amount of money in construction, because that is simply the only way to make a manufacturing business model sustainable. And then finally, again, I do think it comes back to this point about changing attitudes, perceptions in relation to things like the use of technologies, particularly off-site technology.
Thank you.
Thank you very much.
Thank you. Hand over to Jennifer.
Thanks, Luigi. Thanks, Fergus.
Yeah, thank you, Luigi.
Thanks, Luigi.
And my thanks also to Sam and Fergus. A very interesting discussion. I now hand over to Professor Chris Cheeseman, who will chair our 6th session. So, Chris, I'm handing over to you to chair the session.
Okay, yes, okay. Sorry, I was just getting sorted there. So thank you for this opportunity to be part of the celebration, the 10th anniversary celebration for the Centre for Systems Engineering at Imperial. It's a great honour. So this is session 6 on infrastructure life cycles, and I'm joined by Rupert Myers from Imperial and Pete Winslow from Expedition Engineering. So first, I think an introduction about me for those who don't know me. I'm Chris Cheeseman. I'm Professor of Materials Resources Engineering and Head of the Materials Section in the Civil and Environmental Engineering Department at Imperial. I'm also the Director of the new UK CRIC Centre for Infrastructure Materials that is based in the department and which offers almost, well, I would say world-leading facilities for materials research with a particular focus on civil engineering infrastructure materials. So that's quite a unique facility. The new section, the materials section, which I head, brings together a lot of previous work from the environmental and water resource engineering section and the structures section within the department. And it really aims to be a leading centre for research and innovation, focusing on materials and associated issues with infrastructure development. My interests are in, well, formerly actually from the environmental engineering section were to do with end-of-life materials, but increasingly I'm now interested across the whole life cycle of materials, where they come from, how they can be manufactured, where they end up, how we can get maximum value from them, and how we can develop new low carbon materials, and how at end of life those resources can remain as resources and rather than being waste. So promoting the whole issue of the circular economy in the infrastructure sector. So life cycle of infrastructures forms a key underlying theme for much of my research and the research of my colleagues within the Centre for Infrastructure Materials at Imperial. So I'm therefore very pleased to introduce this session. It seems to me that discussing the life cycle in infrastructure, we need to consider the key materials we use. So particularly concrete and steel, but a whole range. We use almost every possible material there is in infrastructure in some way. So we need to consider how we use them, how we can extend their useful life, and how we think about materials at the end of life of infrastructure. Of course, we have a whole construction and demolition waste industry operating in that sort of space, but it seems to me that given the new drivers that exist for change, this is an area where there are significant opportunities for new innovation and particularly systems thinking to have real impact. Okay, I'm delighted to be joined by two authorities in this area. who will discuss various issues. These are first Pete Winslow from Expedition Engineering and Rupert Myers from my colleague from the materials section here at Imperial. So can I hand over to Pete? Would you like to just introduce yourself?
Thanks, Chris. Yes. So I guess my background, I originally did a PhD at Cambridge University in structural engineering. And then since then, I've been working in industry at Expedition Engineering, where I'm an associate director. And actually for several years, my focus was actually sort of architectural structural engineering. So working on projects such as the Velodrome for the London Olympics, the Greek National Opera, Cultural Centre, and several other projects. But actually what I've been doing in more recent years and a growing area that Expedition are we've been interested in is infrastructure and innovation in infrastructure. Doing quite a bit of work over the last 3 or 4 years with HS2 and more recently with Network Rail, looking at decarbonisation, looking at getting more out of the materials, the current materials we have, as well as how do we bring in new technologies. And that's within my role as practice lead for R&D. And I guess probably, Rupert, was a couple of months ago now, we started talking about route maps to lower carbon steel and concrete. When big infrastructure organisations, Network Rails, high-speed twos, and similar types of challenges exist for others as well, Highways England, Environment Agency, and so on, doing large amounts of construction work, how you look at material flows, material use, material efficiency, decarbonisation at that kind of scale.
Excellent, thank you, Pete. Rupert, could you say a few words about yourself, where you're coming from and what your interests are?
Yeah, sure. Thanks for the introduction there, Chris. So I'm a lecturer in sustainable materials engineering. I sit in the materials section with Chris in the Department of Civil and Environmental Engineering. My background, I'm a chemical engineer by training, and I did a PhD in material science. So I sort of fuse these things together. So my focus is, and where my interest sits, is in analysing how we use resources in society. And I have a particular focus on buildings, built environment, infrastructure, and these bulk materials which make up most of the world that we live in. So why am I interested in these areas? Well, I find it quite interesting, or when I entered this, that materials seem to have a lesser focus than energy, but it's quite remarkable that steel and concrete alone, they're responsible for about 20% of our CO2 emissions, just their production, and about half of all the materials we extract from the earth go into steel and concrete. I just found that fascinating. So what we do is we develop science we create science to understand how to produce and use these sorts of materials, but with lower environmental impacts. And so that's important with respect to the CO2 emissions and the resource issues before. One example of this is, for example, cement setting. So if we can accelerate cement setting, then we can reduce less Portland cement clinker. And that means that we can produce less Portland cement clinker and reduce CO2 emissions in industry. And so one particular and kind of a special thing that we do, or that I research in, is that we work on new material chemistry. So things that I was talking about before, new sort of ways to set cement faster, but we link that directly to systems thinking. And I suppose I also classify myself as an industrial ecologist, a systems thinker at the societal level. And we're particularly understanding, how society is using materials and resources, how cities are using materials and resources, how buildings are using materials and resources, and also down to the material level. So we are modeling sort of technical improvements and advancements, but trying to do this modeling at the societal level. So thanks, Chris.
Okay, so you've probably almost answered this question, but my first question to you two is, why should we be concerned about the life cycle of infrastructure? And how does life cycle thinking currently influence the design process? Rupert, do you want to say something on that?
Yeah, sure thing, Chris. So yeah, I think it's quite key that we sort of talk about what a life cycle of an infrastructure is. And so the way that I see it is that we have infrastructure systems. Let's say the London Tube is a good example of this. And we essentially want to maintain this this infrastructure system, and there are others as well. So this is just one of them. And these essentially are maintained, but the materials that we use in them, they have product cycles, or the products we use within these infrastructure systems have life cycles, and they run through their whole life cycles. Whereas the infrastructure systems, they sort of only, we hope that they don't have a failure during their lifetime. So we try to maintain them. So I think this distinction is important. This relates to the infrastructure systems as a system of systems idea, that infrastructure is maintained for a long period of time. The products, they have more tangible life cycles. And so I think that there's a real need to focus on how to improve life cycles of products when we think about projects. So delivering new projects to improve infrastructure systems, there we should be thinking a lot about what products we're using in those projects, because they have these tangible life cycles.
Okay, Pete. Thank you, Rupert. Pete, can I ask you, does life cycle thinking influence the design process at the moment?
It can do, but I think not nearly enough, in my opinion. And of course, sure, there are so there'll be certain projects where it really has influenced the thinking and really has made it a big improvement. I think there is still a very large proportion of design and construction projects where those life cycles need to have a bigger impact. Still, there's a lot more work to do. I guess that what I've personally seen through the work we've done with HS2 and Network Rail is that there are sort of green shoots of change. There is a desire, I think, and you can see for people to actually to do something a bit different, to look over the longer term, and I guess actually the large infrastructure clients are in quite a unique position here, I think, in that perhaps in comparison to buildings construction, where in the infrastructure area they are essentially owner operators. So the people that are commissioning the project to be built or maintained are the people that look after it for the long term, in the most part, have in-house engineering expertise and technical approval authority. So I think there's real opportunity to do something different, to be able to say, hang on a minute, is this the best way to do it? We've got the resource, or we've got the time, or we've got the long-term view to really look over that whole life cycle. We're not just building something and needing to sell it on because of the economics. It's a different model of working, which I think is quite exciting in terms of innovation.
Okay, thank you. Can either of you give any sort of figures or estimates of what sort of carbon and material efficiency gains you think we could achieve by thinking more about the whole life cycle of infrastructure? And maybe you're able to give some examples. Pete, maybe that's a good question for you.
Yeah, so I guess a lot of my work until fairly recently was in the upfront design side, and so perhaps I'm a little bit biased, but I guess in my mind there's many projects where, and not just ones I've worked on, where actually if you look at what is being designed, specified, and going to be built, it's relatively easy wins to reduce the embodied carbon by something like 20 to 40%, without trying to change the code, without needing radical new materials. But basically looking at all the different marginal gains that could be done, saying, can we make those elements smaller? Can we use a lower grade of concrete? Do we need to have that configuration like that? Can we use less cladding? And going through those marginal gains, and when you add them up, actually getting some really quite substantial improvements. I think there's a couple of studies done by Cambridge University over in the last 3 or 4 years that actually they look back at about a portfolio of 20, 30 projects and said, and how hard are they working? Does it need all the material in it that it's got? And the answer is actually they are not working that hard. There's obviously lots of competing factors in there in terms of but typically working at between 60 to 70% of the real capacity of material. So then you say, well, can we take out 30, 40% of what's been put in? And I think we've found that directly in projects, most recently the Old Oak Common roof structure, that we did a sort of a marginal gains optimization process. We then took out almost 30% of the material through these kind of approaches. And so I'd say then, beyond that, more, once you then start saying, well, can we change the production processes or the wider industrial ecology or the wider system, those gains, should be on top of those. So I think there's really quite, big potential there. I think the example I was going to throw in as well is the one of steel, in that at the moment, we know as well in the world that steel, if it was a country, would be probably the third or fourth biggest emitter in the world. There's probably the US, there'd be China, then there'd be steel industry will be straight after that. And I think there's a proportion of that steel that comes from iron ore, primary steel making, and there's a proportion which is scrap that's melted down and reused. And of course, the scrap route is much lower energy. And in a sense, if only we could reduce our demand for steel by perhaps 30–40%, we would quite soon get to a position where there was enough scrap to be able to make all the demand for new steel in buildings and infrastructure could be met by the scrap coming off demolished buildings. If we could take our demand for new steel down by 30–40% as a sort of a ballpark, and which then you start saying, well, if we're looking at that life cycle, we're getting into a more circular life cycle, which can really help us. But we have to get that, we have to reduce demand.
Yeah. Rupert, I'm sure you want to say something about lower carbon concrete, although we should say concrete is a pretty low carbon material. In fact, the fact it's high carbon attached to it is because we use just so much of it. Do you want to expand on that comment, Rupert?
Yeah, sure. I mean, there's a lot of things that I can say. So this discussion is very interesting. I find. Yeah. So with concrete and cement, it's that we use so much of the material. It's such a useful material for us that using less. That's why using less is such an effective strategy. But we use it because it's so useful. There are different technologies, but I just wanted to touch back on really agreeing with Pete, because I was thinking about this event and what the key message was that I wanted to bring across. And I think it's really that, we've sort of focused a lot on the production side of the life cycle historically, but it's really, really hard to decarbonize just based on the production cycle. So you asked for some stats, and so we've analyzed cementitious products, so the cement, concrete, mortar, etc. And about 60% of the emissions are from the production part of the life cycle, but then you have the rest. So you have about 25% in manufacturing. This is currently what we think is going on in the UK. And then you have a lot of potential elsewhere. You have a lot of potential with recycling, for example. And I think the key point is that it's really hard to reduce emissions just in the production stage, particularly for cement, because if you're going to things like carbon capture and storage, that needs to be rolled out very cheaply, because cement and concrete are quite cheap products. So the key thing is that we need these multiple measures, as Pete was talking about. We need to look across the life cycle, which is also challenging. So I wanted to raise that point too. That's also a challenge. But I think there are things that we can do across the life cycle that we all need to do. To your point then about quickly to your point about concrete and cement, Chris, I think it's really important. I think one thing that I think is really important that perhaps hasn't been appreciated so much, as far as I can tell, is just the sort of game-changing possibility of off-site construction, because then you can use or cure cement and concrete in a manner that's most beneficial and improve the performance of that. So rather than selling a raw material mixture, you can sell a thing with a member or a component of specified performance. And that allows you to use game-changing materials technologies like magnesium silicate cements, which is what we're working on here in Imperial, and other technologies. The possibilities just open up dramatically with that, as far as I see.
Okay, we've got 1 minute left, so I need to summarize very quickly. And the other point I wanted to raise is that there is in fact significant opportunity, I think, for carbon sequestration on using some of these materials at end of life that isn't being used at the moment. So just to summarize very quickly, we have to look at materials across the life cycle of infrastructure. The driver is to reduce embodied carbon. We need to think about how materials how materials can influence the delivery and the construction. We need to optimize performance and durability, and we really need to be thinking about the circular economy for end-of-life materials. Yeah, I think I had some more comments to make, but I think given the time, we can probably pick some other things in the discussion sessions that follow. So thank you very much, Rupert and Pete. Thank you.
Thank you, Chris, and my thanks also to Rupert and Pete. A very interesting discussion. I hand over now to our visiting professor from Bureau Happold, Mike Cook, who will chair the penultimate session.
Thank you very much, Jennifer, and for the introduction. Yeah, this is an interesting session from my point of view, and it's been really interesting to get my head around it. It's called Carbon Neutral to Net Zero Pollution, Built and Natural Environment. And I kind of ponder on it because it's full of really important words, as you can see, and so there's a heck of a lot to be considered here. I am, as Jennifer mentioned, Dr. Mike Cook. I'm a civil engineering partner at Bureau Happold, have been for a very long time, but I am a visiting professor of creative design at Civil and Environmental Engineering Department at Imperial, a thing that I've enjoyed doing for something like 12 years, and I hope the students have learnt a lot. I have learnt a huge amount by teaching there, and I'm now very involved in the profession, across the profession, on climate emergency transformation, as I might call it, working with Royal Academy of Engineers, the various institutions, civil, structurals, and so on. That's me. For me, this, as I say, very interesting topic that I'm really delighted to have been asked to introduce in this very short period of time. My own work has opened my eyes to the need for a really urgent and pretty radical action based on new perspectives. We are looking for a really substantial change of direction rather than just improving a bit what we've got. As I say, and repeating others, what got us here today will not get us where we need to be tomorrow. So this isn't a reshuffle the deck chairs job. Now, we all know construction can bring massive social benefits. We can't live without it, if you like, but it does bring with it massive disbenefits. And these disbenefits go way beyond greenhouse gas emissions that we're now currently talking about a great deal, to destruction of supportive natural ecosystems. And this is something that this topic touches on. So the transformation we have to make is going to require us to assess the value and/or the harm that construction causes across far wider boundaries than ever before. We'll have to include natural world as well as man-made, and this isn't something that we're often trained to do, certainly as civil engineers. So a systems approach, I'm pretty sure, is what's needed, and it'll allow us to introduce, the necessary different overlapping issues and complexities, but do it in a way that helps steer us towards some net positive outcomes for us all, for man and the planet. So I think this work on net zero pollution, interesting word, is developing something that could help point the way forward, which is why I'm so keen to hear more. So the key challenge for the future, I think, is this transforming our development from being degenerative, dare I say it, to regenerative. And this means not just eliminating the greenhouse gases and holding global warming within government targets, which of course is a big aim in itself, but also regenerating a supportive natural ecosystem, the services that we rely on from nature that are essential to give us a healthy planet for future generations. This is perhaps the big thing. This is about the future generations. So I think net zero pollution is a good way to start. So let's get going. And first we have with us Anna Mujic and Mark Stettler, who are going to introduce us to the subject and answer questions. So maybe I can ask Anna, maybe you could introduce yourself, and Mark, you could introduce yourself.
Great, thanks, Mike. My name is Anna Mujic. I'm a senior lecturer in the Department of Civil and Environmental Engineering, and my main area of work is water management, and I guess that's the link with also this theme and why we started thinking about the concept of net zero pollution. So in water management and in the water sector, which is my background, so my background is civil engineering, the link between the built and natural environment is intrinsic. So everything we do on the built environment, which is the water infrastructure and supporting infrastructure for water supply, water management, food sector, and so on, is directly linked with the environment, which all the resources come from, and also all the pollution goes into. So in the concept of pollution, the most direct one and the one that we think about a lot is the issue with the water quality. And if some of you may have seen the article from Guardian on Monday on the problems with the combined sewer overflow, it's quite big societal issue, even in the very developed countries such as UK. But the other part of the story is something that we call the indirect effect. So generally the footprint of the land use change, footprint of the water obstructions, which all have the impact on the natural environment. And what happens then is that the ecosystem services we rely on also change. So it is this feedback that I'm particularly really interested in, and something that I would like to discuss in this session. What we do about it, we are modelers, so lots of sessions previously mentioned modeling, mentioned data. We are trying to model, we're trying to simulate, in particularly in two aspects. So something that was mentioned previously in the data-driven session, improving the operation through better understanding of the holistic system, and finally the long-term planning. So how we go from now, and what is that sustainable development in the context of water management. So that's all from me. I'm looking forward to the chat. So I'll give it over to Mark.
Thanks, Anna. So yeah, I'm Mark Stetler, a senior lecturer in transport environment at the Department of Civil Environmental Engineering. My research is focused on how the transport sector impacts on the environment and what we can do about it. So we're all aware that the transport systems that we rely on are essential to our society. They facilitate the movement of people and goods. However, they're a significant contributor to greenhouse gas emissions, to air pollution, to noise pollution in our towns and cities. And one of the starting points for this, when we originally conceived this idea, was that the infrastructure is not passive. So our transport infrastructure that we build determines the transport modes that we use. And because we design infrastructure to last for decades, the decisions that we make on transport infrastructure, such as upgrading or building new transport infrastructure or roads, have consequences for decades. So we're currently in a really interesting situation where the coronavirus pandemic has radically changed travel behavior. Social distancing potentially has significant consequences for public transport in the near term, possibly in the midterm. We've seen positive increases in cycling and walking, but I think really at this time we need to be taking a systems engineering perspective to look at approaches for solving these challenges, moving people around safely without us all sitting in cars and significantly increasing our environmental impact.
Thank you, Mark. Really interesting, and it's interesting that Rupert Myers is also working with you, I believe, on that. He's certainly been taking part in our pre-discussions, and so it was interesting to hear from him. I think with the three of you, it's a very diverse set of experiences that you're bringing to this topic. I'm going to start rolling some questions out. I think we've got some coming in already, but before I pick up on that. One of the things I just wanted to clarify, it's something that I've been talking to you about recently. You talk about carbon neutral to net zero pollution. Pollution's become the big word here that you're focusing in on. Now that means a lot of different things to people, perhaps, and I think you're using it in a way that's worth explaining. I don't know, Mark or Anna, if you'd like to just underline what we're talking about here and why we're talking about pollution.
Yeah, so the word pollution, we're being deliberately broad when we use it, and we're using it to mean the addition or change in a quantity of a solid, liquid or gas or any other form of energy, be that heat, sound or radioactivity, to the environment at a faster rate than it can be dispersed, diluted, decomposed, recycled or stored. And so it's kind of a very broad term that catches a whole load of extremely diverse sources of pollution and different types of damages that result from that pollution. Just sort of rolling back on our thinking, typically when we consider the effect of human activity on the environment, we use what's called the impact pathway. We think about it in terms of the impact pathway. And in brief, what that is that human activity leads to emissions of some form. And then when released into the environment, we call this pollution. And this pollution ultimately causes some damage, be that on the human environment or the natural environment. So it could be an impact on people's health or on climate change or on ecosystems. Now, infrastructure enables these activities and therefore is related with a direct source of pollution. For example, cars driving on a road is a direct source of pollution. But there's also pollution associated with the materials, the land use, and the life cycle of that infrastructure. So, I mean, ultimately, the natural environment in which this infrastructure stands has an impact back on the infrastructure system. And so by focusing on the pollution as the target, we think that this breaks the impact pathway chain and also forces us to consider the various different forms of pollution that exist, and also the many different ways in which pollution can be reduced. So it sort of brings it up the decision and design decisions, because there are different ways in which pollution can be minimized.
Thanks, Mark.
Maybe if I can add, Mike,
yeah,
a few comments, because I think this is also really important if we talk about the systems approach or systems angle in this, which is really linked very much on the role of infrastructure and what we can do about it. So when we were discussing, and you're completely right that, you know, Rupert, Mark, and myself have spent basically the whole lockdown discussing this once a week, and it's interesting that we approach this from three very different perspectives. Mark from transport, water, and then Rupert from materials, and we came up with 4 reasons why we think this is really important, and why maybe it's a bit different than the narrative around the pollution, maybe prevention that exists for many years now. I think the aspect that we really want to focus about, and I think you mentioned that into your introduction, is about these benefits. I think we see it more as an unintended consequences, and we can expand on that a bit later on. So we have carbon as one issue, but if we fix carbon, so if we go net zero carbon, did we solve all our problems? So is it any feedback that might happen which we need to be aware of? So the second one is on the positive side. So we, you know, when we think about the solutions, what are those solutions that have multiple benefits? And we work a lot on, say, green infrastructure as an intervention that is beneficial for air pollution, flood management, water quality, and so on. And then the third one is really kind of thinking about the infrastructure in the context of sustainable development. And if we look at the Sustainable Development Goals, infrastructure links with quite a few of them, not only sustainable cities and so on. And then the final one, which I think was touched upon maybe in the earlier discussion, and you know, we can see how much we can go into it, is about the responsibility, which is really very important aspect if we talk about the pollution. So on one side we have the regulation, and this is primarily how things work. But if we talk about the pollution and what Mark mentioned, if we expand the analysis towards impact pathways, damage, and the functioning of the environment, it's really now on the polluters, and who are the polluters and what's the responsibility of the industry and the whole society if we talk about the future development.
Thanks very much, Anna. Now, actually, we're getting some really interesting questions coming in online, so we should move across to those. So brace yourselves. I mean, some interesting stuff. There's a question, simple question, you know, is net zero, I guess net zero pollution, realistic? And then while you think about that, there's also even a question, should we be targeting a net, it says net negative, I suppose net negative pollution in some way? I mean, I guess in terms of sort of regenerative thinking, as I was talking about, to actually start to improve, not just minimize harm. So net zero, is it realistic, and can we do better?
Do you want to start, Mark?
So Yeah, I can start. So, I think net zero is potentially more realistic than absolute zero, and so this is a point that we've discussed over and over again, and thinking about, you know, could we target absolute zero pollution? And in certain circumstances or for certain types of pollution, that's completely necessary. So, for instance, if you have a toxic chemical that minute quantities will cause significant damage, then clearly that's something that you want to minimize to zero. But there are other forms of pollution where potentially a net approach, where you accept some form of pollution at one time in one place and trade that off against taking away pollution from another place at a different time, could work, and it could be more pragmatic. So that the most common example of that is CO2, and the fact that we accept that we can emit CO2 in one place and take it out of the atmosphere in another place. So that's a case where net zero is pragmatic. But yeah, I would say that there's other instances where net zero approach is probably not appropriate, and in those circumstances, an absolute zero would be more appropriate.
Thanks, Mark.
Maybe if I can just add a quick example.
I'd like to warn you, we've got lots of questions rushing
in.
Okay,
let's move on. Let's move on then.
Well, okay, sorry, Anna. The next thing to come on to is whether by going for net zero pollution, or whether it's net or not, does this framing make it easier to find opportunities to deliver multiple pollution reduction benefits? You know, by going for pollution, does that broaden things? And the questioner asks about what can we learn from catchment management principles. That may mean more to you than me, and excuse my ignorance. But I think it is an interesting point that actually there's some value in the word and the giving approach and a new approach. Would one of you like to talk about that?
Well, I mean, maybe I can start, kind of building on what Mark was saying on the zero and net zero, and when it's applicable, when it's not. I think maybe one point to clarify, and maybe in my mind, what net zero means is it is I think, very pragmatic approach. I think it acknowledges that we will be developing, and that if there is that infrastructure is what we call critical assets, so something that enables the society and the quality of life we have. So we want to have infrastructure, and we are pro-development, but the question is what that development should be, and that there is a term to say infrastructure is critical, but it's non-neutral, and I think that non-neutrality is the key thing. So in my work, what it means is that we need to see the built environment, and we need to see that natural environment, which is critical for the functioning of the system from the resources perspective, but also where the pollution goes into. An interesting aspect about the net zero thinking in that case is if we start from the environment, which comes to that catchment-based approach. So if we start from the environment, or the state of the environment, as a key guidance, then we can see infrastructure planning in a completely different way. So then we can operate the infrastructure in a way that we give the environment the capacity to deal with the pollution, say leaving more water in the system, if we can simulate, for example, obstructions and discharges at the urban scale at the same time. But it's really thinking about the infrastructure and the state of infrastructure as a starting point for our infrastructure planning.
Thank you, Anna. Anything to add, Mark, before we move to the next?
No, feel free to go to the next one. There seems like there's a few interesting ones.
Well, yes, I think so, and it's great. Actually, I think there is real interest in this topic. So the question direct is, over the last 10 years, and looking at automation across many processes within the built environment, why do you think that achieving net zero pollution is still challenging? Is it a people, a process, a technology issue, or what? Where should we really start? That's quite a question.
I think I would probably say that net zero pollution is not currently target. So the target is to pollute the lower limit set by regulations in most sectors. And so I think by setting as a net zero pollution target, it would change the mindset of an organization and would open up opportunities to make it possible. I mean, certainly there are challenges and it's extremely ambitious, but I would say it's probably not been thought about in this way.
So in a way, where we should really start is by using terms like this that people that kind of starts to really raise people's broader thinking about the issues, you know, beyond carbon, right into the heart of what we're doing to the environment. You've started. Sorry, Anna.
Just a final point. I think it should really focus on thinking about the demand and dynamic control of the system, which was mentioned before, which I think we should all really come back to.
So
right.
So I think we're going to have to move us on. And thank you very much, Mike, for chairing this session. And thank you also to Anna and Mark for being part of it. And I realise it's really just a taster of quite a large topic area. And there's a lot more to talk about in the breakout sessions.
We hope we've whetted your appetites.
You definitely have. Thank you, Mark. Yeah. So we've had 6 tasters of our emerging research today, and I just wanted to recap a little ahead of the final session with Mary and Judith. So we had the Minister talking about the importance of systems engineering and about scaling up of systems engineering approaches in infrastructure. We had sessions on complexity and resilience, systems integration, data-driven systems engineering, transforming construction, infrastructure life cycles, and then just this session now on carbon neutral and net zero pollution. I was very struck by something that Rupert said around the different kinds of concrete mixes and materials that you can get when you move to an off-site strategy. And I think that's been a theme through the day, from Ray's interest in off-site to the interest in transforming construction in the session after coffee. And we've really touched on things around operating infrastructure, around complexity and resilience of operating infrastructure, around delivery and how we intervene in infrastructure and see projects as interventions, and about adaptation over the longer term. I want to just quickly flag 3 of our projects that we're funding this year, and say a couple of words about the future before I hand over to Mary to chair this next session. So we have 3 projects that we've funded this year. Every year we've been funding seed funding research projects. The first of those is by Rupert on system-wide technology policy mapping for low carbon buildings. The second one is by Kate Simpson on identifying eco-innovation in the building retrofit sector. And we've decided to take discussion of these into webinars in September. So she will give a webinar on the 23rd of September. The third one is around a framework for assessing public occupancy risk in buildings. And Georgia Bateman is leading that. And that is also very, very timely with the COVID issue that we're facing at the moment, and we have a webinar forthcoming on that on the 30th of September. We will also have a kind of distinguished webinar with Andrew Wolstenholme and Professor Olivier Devec from MIT, and we're going to do that as a webinar also in September around the launch of our report. But I wanted to see if you'd sort of hope that you'd enjoyed the journey with us through the day, and also highlight that we are a community of scholars, some of whom you have met today, but there are many others, including postdoctoral researchers and PhD students that are standing behind the scenes. Through lockdown, we have been coming together, as Anna mentioned, and exploring systems engineering and innovation together, and writing an agenda for that. And that we're a transdisciplinary, quantitative, entrepreneurial, engaged community across a number of departments. So you've heard from people in civil and environmental engineering, but also from across the college in Dyson School of Design Engineering, the Business School, and Computer Science. And this links very nicely to our academic strategy. I'm not going to say too much about that because I'm going to hand over to Mary Ryan, who can talk well about that. But you will notice in that strategy a lot of the approaches and the ways that we're thinking about the big challenges have a systems connection to them around sustainability, smart, resilience, and healthy. So I'm going to hand over to Mary to chair this next session. Thank you.
Thank you, Jennifer. Yeah, so it's my pleasure to host this final session of the morning with two speakers I don't think need any introduction. Jennifer, we've heard from already this morning, and Dame Judith Hackett, who is a long friend of the college and an alumni of the Chemical Engineering Department. And I'll hand over to Judith in a minute to introduce herself more fully. So I'm a professor of interfacial nanoscience in the Department of Materials. I hold an RAN chair in that space, and that probably seems a long way, as you can imagine, from systems integration. But of course, the reason to be interested in nanoscale materials and nanoscale interfaces is that they have macroscopic ramifications in both in infrastructure and in energy systems. And so understanding how you get from the nanoscale to the macro scale is a big challenge. And that's a huge integration challenge, right? And in a kind of a microcosm of how you can build up from something small in a system to understanding the system totally. But the reason I'm really interested in systems engineering is that I'm also the Vice Dean for Research and Engineering, and within that role, I'm leading the college's academic strategy drive on the transition to zero pollution. And that's a strategy that actually is a bottom-up strategy. It came up from having discussions and workshops within the Faculty of Engineering as something that colleagues across the faculty thought was something we should be looking at. We should be thinking more holistically about the environment and how engineering impacts the environment, and a way to go beyond just thinking about carbon, and a way to stop thinking in silos, because siloed thinking leads to unintended consequences. You know, we've heard this morning about challenges in transport, challenges in building materials, and if you fix one problem, quite often history tells us if you only focus on fixing that problem, something else comes to bite you later on. So replacing ozone damaging gases, we replaced all of those gases. The replacement turned out to be greenhouse gases. So we didn't think holistically about the planet as our system. And I think that's something where I'm really excited by all the interactions I've had with colleagues. And Mark and Anna did a really brilliant job of elucidating why we think zero pollution is the way forward. So I'm going to hand over to Judith to introduce yourself briefly. I just we'll be interested in your thoughts around systems engineering and systems thinking going forwards, and we've put to 2030 here, but I think 2050 is a key goal as well for the UK. So 2030 and beyond, Judith, would be nice to hear.
Okay, well, thank you very much for the introduction. Really delighted to have this opportunity to join this celebration of systems engineering in civil engineering. As you heard in the introduction, I'm a chemical engineer. Did my degree at Imperial rather longer ago than I care to think about, but I guess what that means for me is that having been throughout my education and my career very much focused on dynamic chemical processes, it feels like systems engineering and systems thinking is now part of my DNA and always has been. And so it really is great, I think, to see this greater awareness that is building around systems engineering and systems thinking. I do have a concern that I still think it means different things to different people. And that's really come to the fore in some of the work that I've been doing for the Royal Academy of Engineering. I chair their Safer Complex Systems work stream now. And what we're looking at are ever increasing, ever more complex systems and interactive systems. And I think the point you've just made, Mary, about if we fix a problem in one dimension and create a problem in another dimension, some of the tools that we use and that traditional systems engineering use are struggling to cope with the complexity of the challenges that we now face. So one of the first things that comes to mind for me in this space is that we need new tools and techniques. And it seems self-evident to me that those need to be interdisciplinary. I see very little point in us all staying in our disciplinary silos and developing those tools and techniques. A lot of what's failed to happen thus far, I think, has been for precisely those reasons, because tools and techniques that exist within one engineering discipline have not been translated and transferred in a way that is meaningful to a different part of a different engineering discipline. So I think for me, step one is we've got to get better at sharing, better at collaborating, and recognize the urgent need to develop those tools that can deal with the level of complexity that we're now trying to accommodate in many of the projects that we get involved in, because it is about the built environment needs to be safe. It also needs to tackle the environmental challenges. It also needs to be more productive. We have to tackle all of those problems at the same time. And that means finding ways of ensuring that we are dealing with and mindful of the fact that we're dealing with systems of systems. And that for me is the key bit in all of this. For me, I guess the vision for 2050 is that I'd quite like us to at least think about blurring some of those disciplinary edges, because I do genuinely question the relevance of our disciplinary silos that we've operated in that have been right for the past, but are they right for the future? I don't think so, quite frankly. The fact that I did chemical engineering at university was because I was interested in chemistry, but have I found myself operating as a process engineer? Yes, for some of my career, but not all of it. I think what is the most important thing for me is that I think and act like an engineer, and that means I look at things as systems. And that's applicable to any discipline, and I think we've got to get some of those foundations of what it means to be an engineer built across all disciplines, and the bit that we add on in terms of our specialization comes at the end rather than the beginning.
Okay, thank you, Judith. And I think in that brief moment you've answered my very first question, which was going to be around should systems thinking be embedded in all of our undergraduate courses, not just ones where there's process systems. Well, so let me push that a little bit then. So how do we make that embedded? Is it something that universities will just do because the students will start to demand it, like they're demanding computer training and they're starting to demand design type thinking? Or should that come as a push from the professional institutions? Or is it a combination, do you think?
I think it's a combination. I think it would be good if it could come from the institutions. I think, and I can say this because I've been president of my own institution. I think they have to change their approach. They have to change from being behind the curve to in front of it, and that's quite a big ask. I think it will always be difficult for them, because if you think about their membership is very often based in people of my age rather than the people who will be the engineers of the future. So unless we raise awareness of the need for this, I think it's always going to be challenging for the institutions to lead on this. But I think the place where it can really start is in universities. And I think for our engineering faculty at Imperial and other academic institutions to start working across those disciplinary boundaries and modeling that behavior is probably the best and the most powerful way to start. I've said before, when I went out to work in industry, I immediately found myself working with engineers from other disciplines. The sad thing is that I think within the academic system, we often fail to replicate that in design projects and all of the rest. And so if we could start by doing much more interdisciplinary working in our academic institutions, that would be a great start.
Yeah, no, I think we're in heated agreement, and you know, the centre that Jennifer's been leading is a great example of how that can work. Jennifer, I wonder if you could just comment on any challenges you've had, or has it all just been very positive in bringing these different disciplines together within this centre?
Well, I mean, I think we've taken a transdisciplinary approach to bringing both researchers and academics together, and I have to say that, you know, it's been one of the sort of silver linings of lockdown, if you like, in that we've managed to get people together across college, you know, in calls to have real discussions about systems. And yeah, if you take the speakers from the last couple of sessions, so, you know, Rupert in materials, Anna in water, Mark in transport, yeah, we've been, I almost forget what their specific interests are, because we've been having general discussions about systems and how we think about systems and how we might think about infrastructure systems starting from nature. So starting from the natural environment that all of the, you know, and our language becomes quite important here, and we've not really worked that out. So how do we talk about the natural environment and then the built environment that sits within it? And so how do we think about the system that we're trying to model, and how do we look at the modeling assumptions that we have, you know, and how we set up models, how we parameterize, how we quantify, you know, and what boundaries we set, and, you know, that really matters when we start to talk about things like pollution.
Okay, so we have a question in the chat that kind of links to the idea about nature, and you know, the systems that nature has evolved actually do a lot of the things that we aspire to do from a kind of artificial built nature, and so do you see nature as a force for innovation that we could learn from? I mean, personally, I would be very dependent on my colleagues in other bits of the college to address that, but it's certainly something we've been exploring. And I think to respond to Judith's comment, you know, we've really been starting to do that transdisciplinary sort of work across engineering. Okay, I think maybe we'll pick that up in the breakout session, Alex, if you want to join later. So we have one quick question, and it kind of links back to something Ray said very early this morning about respect for engineers versus educators and medicators, and a little bit around the trust and citizenship that was raised by Kate later on. And of course, medicators and educators have first-hand interaction with people, right? Whereas engineers, our interaction with people are mediated through the infrastructure and the products that we design. And you might say that systems engineers have a second or a third-hand interaction with people, and it's noticeable that people haven't really been discussed in all of the discussions this morning, largely. So how do we put people into systems engineering, and how do we explain to people what systems engineering is doing for them?
Great question, Mary. And I think that lies at the heart of how we have to change as engineers. If you look at the way in which we in the Royal Academy of Engineering are now talking about ourselves as part of the new strategy, it's all about that we as engineers exist to develop solutions for society. I think that's a breath of fresh air, actually, that we stop being quite so much in love with the structures that we build and start recognizing that our role in the world is to develop solutions for society. And once you do that, all of these things about addressing climate change, building buildings that are safe for people to live in and use and work in and all of that, it becomes part and parcel of what we all need to do. So I think there is a real element there of us needing to recognize that part of that problem is because we've hidden behind the structures rather than recognizing our social contribution, and that lies at the heart of what we do.
Okay. Well, I think that's the perfect answer, and I think I'll probably leave you with the last word on that because we're out of time. And there are lots of more questions coming in, so hopefully we can catch up some of those in the chat afterwards. But I would just like to thank Jennifer and Judith again for your great contributions. Thanks.
Thank you, Mary, and thank you for chairing the discussion, and thank you, Judith, for joining us. Very interesting conversation. So I'm just going to take a couple of minutes to close the webinar ahead of some further breakout sessions around these topics, and you're very much part of helping us shape this agenda as we go forward. And I also want to say congratulations and thanks to the team. I can tell you there were a lot of people running around behind the scenes this morning, and hopefully it looks smooth on the webinar. But I have to thank Tim Gordon, who's the Centre Administrator, and Jenny Jambona, and the research team, and all of our panel and breakout speakers. So thank you, and congratulations of 10 years of the Centre. So I'm going to end the formal webinar. Please do join us to carry on the conversation in the breakout sessions, and join our newsletter to see the details of the webinar and the report that will come out in September and October. Thank you. And just to say that the details of the breakout sessions are going to be in Teams, and the link to them is in the chat. Thank you. Bye then.